Hello, hello. Hi. Okay, today we are going to start making the actual language, right? I mean, remaking the actual language. I think the formatter and the highlighter is good enough. I also did off stream a little bit of the thing, which I didn't do, which is actually making the syntax extensible. So, like, we have the syntax annotation inside the code, which introduces new syntax, which we can use later. So in this case, for example, I introduced the foo syntax, which is the foo keyword followed by some value. So we have with this foo being highlighted as a keyword, but not before. Yeah, that's how it was working earlier. I might want to change it, but for now, this is good enough. I just feel like that for better better custom formatter, we actually need to write similarly to how, so the custom syntax is supposed to go through macros to generate code, like using simpler syntax, I guess. Similarly to that, we can have a code that is actually doing the formatting for the formatter. So executing the formatter with custom would actually require interpreting the code, I think. Um, yeah. So we are going to start on the compiler and interpreter. So the way it's going to work, we have the interpreter doesn't interpret the AST directly. We first convert it to the high-level intermediate representation. And that's going to be done by the compiler. Not going to compile to native code or anything. It's going to compile to the intermediate representation, and then we're going to interpret that. So we are going to add a couple of packages or projects or whatever they call this in Dune. So we have a compiler, Dune. What's it called? It's called like library, I guess, right? So we have a library, which is going to be called cast compiler. We're going to have a library called interpreter. Cast interpreter. And and we are going to have the intermediate representation. So this is a cast intermediate representation. Let's start with this thing. Cast intermediate representation. So what do we have here? Basically, I want to compile down to, like, I don't know, maybe it shouldn't be called intermediate representation, but just AST, but this is the one that doesn't have the custom synth stuff anymore. So we just have expressions which are going to be what do we start with? Something simple, right? So we can, like, apply a function, right? We can apply a function, or I guess, hold on, we are going to, first of all, we're going to have some information attached to the things, like spans and stuff, right? std, you cast util is going to be here, open std. Cast util. I need to run the LSP support like that. So we have expression which has shape like that. Expression shape T. That module shape. Hacks. Oh, Deagle. So what can the expression be, right? It can be, let's see, we can apply a function, right? Or let's do the simplest one, right? How do they usually do it? Like the so I called that binding before. I called that binding before. Let's just do name string for now. So we can basically refer to a variable that exists, potentially at runtime, right? So that's the simple one. Then we can also create a new lambda. I will just call it a function, right? So this one should be a function. Oh my god, both fun and function are keywords in OCaml. How do you even name things? What's a backtick? Like they sometimes do the backticks here. I saw that. Or what? Do they not? Okay, function. Okay, maybe because of that we call it a lambda. A closure. Whatever. Closure. Closure has a argument, which is a pattern, and has a body, which is another expression. Wait a second. Is this even possible to write in OCaml? I need module. So like, I guess I can if I do these types all at the same time like that. You know, type this, type closure and shape and expression. Like I can do that, I guess. And then like if I want to be put into a module, I will just say that type T is shape. Right? Yeah. Okay. What else? So we have so we need to have patterns. This should be specifically expression shape. Module expression. Module shape. So now we need a pattern. And what's a pattern? A pattern, for now, we're just going to have the simple one where the pattern is a single binding. Like that. No. It's not just a binding, it's going to be having pattern shape too. So pattern shape is that. But then pattern itself has the shape and span also. Right? So basically for every node of the intermediate presentation, I want to have some information attached. There's going to be spans, there's going to be type information, and some other stuff, potentially. Yep, so we do like that. pattern struct. D is pattern. Shape is struct. D is pattern shape. Okay, so we have now expressions, which is either a binding or a closure. What doink? What do you mean? What am I doing? Or what does that mean? What does doink mean? Doink has a few slang meanings. Primarily, it can refer to a fool, a jerk, or a worthless person. Did you just call me a worthless person? That's what doink means. Ah. Alright, alright. I'll remember that. I remember that. Deagle, I remember your name now. To have sexual intercourse too, yes. That's another meaning of that word, apparently. What I'm doing, I mean, I'm beginning to implement the interpreter so that we can actually do something with the language apart from just highlighting and formatting it. So I'm starting to do this expression pattern. Pattern is just bindings. Let's just do immediately that pattern can be a placeholder, which means that it matches everything. So placeholder is something like, you know, we can do underscore. Wait, but what are you doing? That's a real question. But I just answered it. What do you mean? I'm writing code that is going to be the interpreter. I'm going to write a language. I'm making a programming language. But I just started this file. Yes, this file is specifically about specifying this, what I call intermediate representation. Although usually you call this AST, I think. But this is going to be after processing of the compiler. You already have a language, right? Yes, but I'm rewriting it from scratch in OCaml. We started the rewriting like a week ago or something. We have already some new features that I didn't have before, though, like syntax highlighting, like I said. We have syntax highlighting here, and we have formatter. So I can just do this, and it will format the things for me. All in VS Code with an extension. And now we're going to redo the other parts and maybe improve on them too. I'm not going to do assembly. Okay, so patterns are these two. This is good enough. Expression is a binding, a closure. An application. Wait, we can have recursive modules, right? We can have recursive modules, but do I want to have recursive modules? Like, because I want to have, like, namespaces here is the thing. Like, this should not be just closure. This is not just a closure, right? This is a closure expression. So I kind of want it to be inside over here. we can have module and hello Nigel. A camel modules. Why did my dependency graph have Unix? I have something like Unix dot is a TTY. This function apparently is just on Unix, so I guess the language is not going to work on Windows now. I need to have like something. This is for highlighting in terminal. I could highlight without checking if it's just a TTY, but I want to not highlight if I'm piping to a file, for example. Or even codes on Windows. True. So here's the first like actual problem with like the way I like why is it difficult, because we have like this recursive stuff, right? We have this recursive stuff, expression. I mean, we don't have a real recursion yet because pattern does not depend on the expression, I guess. Can a pattern depend on the expression? I know. Not sure. Anyway, how do you do recursive camel recursive modules? Just for like specifying these types, I want them to be it's module rec and yes, okay.
Hello Pew.Apomin.
Hello Pew.Apomin. Hello, hi. Module rec. Recursive modules require an explicit module type. Okay. That's annoying. Alright. So I can just say then, like, I'm just going to rename this then to expression closure, I guess. And this is going to be expression apply. So instead of having module, we're just going to like underscore to prefix the types. Sure. Okay, so apply is going to be having a function, which is an expression, and the argument, which is an expression, right? There you go. So we can create closures, we can apply, we can have bindings, and let's also have some like constants, right? Let's have constant of value. So here's the problem. What is the value? Should the value be defined here? This is where the problem is, I guess. So we have the intermediate representation. Intermediate representation can contain a value. A value is potentially a type because we have types as values. So this depends on that. This depends on that. At the same time, a value can also be an intermediate representation because we have that as a value too. So we have this dependency. And then type is also potentially has values inside. I don't remember the reason, but yeah. So like we have all of this highly recursive stuff, right? But I kind of want to maybe like I wanted to try to split this into separate modules, but how do I do this? Is the question. How do I do that is the question. I feel like to do that, we need to have this. I need to have a module make. Module make. We need to make it a functor. Instead of having actually recursive modules, I'm going to make this a functor and having a dependency here. So this is depending on the values. Sig type t end. Can I just do this in line? And we depend on the type, which is also just that. Like for the sake of defining the intermediate presentation, I just need to know what's a value and what's a type, right? I don't need to look further, maybe. So a constant would be a value.t, right? So then we will have two more libraries. One of them is going to be called value, and one of them is going to be called type. This one is cast type. Cast type will depend. This is weird. I don't know. Maybe like putting it into one. Like that's what I was doing before, right? I just had like 20 recursive modules, but OCaml is not very good when working with recursive modules, right? So we don't want that. And together they're a value type. Cast value. Let's just see here, for example, right? We have a value. So value can contain a type, which means that value is also going to be a functor, which depends on what it is a type and what is an expression too. C# has a reference and value types. That's a reference to that. So, you know, we have values and values. So, module module shape is struct. So value can be, let's just say for now, we can have an integer. Let's just say int 32 of int 32. Or it can be a type of type. Right? That's what we want. And then we have the type value. So this is shape. Type value is shape is shape. And we might have some other parts inside. Let's have this simple value for now. And what about the types now? So the type will also depend on the value, right? So they depend on each other. I cannot have a type called type, right? You know, camel, because that's a keyword. What do I call it? I just call it t, I guess. We will have type.t. like that. For now, we do this. So what's the shape? It's going to be an int 32. For now, we just have that. So why does this depend on the value though? Hold on. Maybe type does not depend on the value. We can check the old stuff. Crates. Cast. So like in this like everything just belonged to the same crate. So being recursive wasn't really difficult. Here's all the types. Oh, I can call a type a tie, like we do in Rust, tie. There you go. That's what we do in Rust. So we have booleans, int32, char string, just your normal types, and then. So what's the one that contains a value inside? Wait, do I even contain a values inside here? Maybe it's not recursive actually. I feel like it, even if it's not, it might become recursive later. We have potentially like the template. The template contains a maybe compiled function, which contains the expression basically, right? Like a closure, and a closure contains the body, which contains the expression, which can contain a constant, which can contain a value. So in that case, right? So the correct so we don't have this dependency, but we have this dependency. From the type depends on the intermediate representation, because the type is potentially that. But maybe it's because of the way I did it. All right, let's just have for now no dependency. We're just going to have a module make. I will still do a make though, just in case. I will add the dependencies later, I think. Right? Yeah. So there is this, and there is also the type of the types, which is type. Right? Since I have already made type as value here, so this is the values. So the type of values is all of these variants over here. Maybe they don't even need to be in its own. I don't know. Why am I splitting this? Because I don't want to have big modules, right? Yeah. And then I think I will have the thing that combines all of them together. So we have types, which so this is going to be cast types, which depends on value, type, and intermediate representation. Let me rename type to just tie here. How fast do you compile at the moment? It's pretty fast. Dune build. Remove that. I'm Dune build. So like if I build from scratch right now, this is not instant. It takes 3 seconds. But this is from scratch, which like never happens, right? I never do from scratch. But I basically have no external dependencies almost. Also, so far 10 times improvement. Yeah. We'll see how, like, this is just the beginning though, right? I've barely written anything. So we'll see how it goes later. but it's supposed to keep being fast, right? Okay, so here's the idea. We have cast types, and this is the thing which will have which will specify what's the type. So we are going to have recursive modules. What's a type? A type is going to be cast type cast type dot make, right? But recursive modules require an explicit module type. So this should be cast type dot s. I think this is what they usually do, right? So we have a module type s is signature, and can we have like this also? This is of type s. Okay, there we go. So we have a type t, and then we have a module shape. Is of shape s. Well, but shape depends on that, kind of, right? How do you usually do that in OCaml? I don't know. Any people who write OCaml? Something like that? I mean, I can have an inline signature here, right? Just that. Yeah. We can do that. That's maybe cleaner. So, like, what do we expect after we make the type? We expect just to have the type t and the type of the shape. But type t should also, like, so that I can access the insides, we should have that shape.t, right? Like that. There you go. This one says declarations mismatched. Type T is type, is not included. The first is abstract, but the second is record. What? Signature mismatch. Type declaration do not match. Type T is type, is not included here. What if I say that? Then it works, but isn't that the same thing? Okay, sure. Type. Yeah, sure. Sure. I thought it would be the same thing. Okay, so yeah, and then that cast OCaml restart. Okay, we have type, then we have value, which is cast value as is cast value make. So value depends on the type. Like that. So let's have also module type as sig and make type. So value type t is shape t, where we have module shape is sig type t. Like that. This should have s. And if I do that, then it doesn't match. Wait, but what if I don't do that here? What if I don't specify the type like that? What if I just say this? So this one now says that signature mismatch. Yeah, that's the same issue now in the other place. So I want that to be here to catch the problem earlier. So we must have that. Okay, fine. Okay, and this works, right? So now we basically I'm going to be opening the this package, this library types, which will like have no longer abstract, but now these are recursive. But when I just make them, I make them as functors. I don't know. It's weird, but I don't know. Maybe that's how you write OCaml. And then we also have the this, which is cast ers is cast er make. So the integer representation depends on both values and types, right? So we do it like that: value and type, right? So over here we also have module type s sig, and so what do I expect from an intimate representation? I have a module. So the intimate representation has expressions. It has patterns. Wait, is it even possible? Hold on. Because over here, I need to specify that the pattern is... So we have a pattern type T, and we have expression type T, and these ones should be... I should know about them, right? So there should be a shape. Where it should be shape T, like that. So inside of each of these, we should have module shape. Like that. Which they both contain T inside. Wait a second, but like since I need to be working with this from the outside, the shape should also be exposed. Yes, yes, yes. And that's the problem. So type T is like I need to actually write this out. So is it impossible to write this in OCaml by splitting that in modules? Because once again we have recursion here, right? Like, so because this is all that the outside code is going to see, I need to actually like know what the shape. So like this should be duplicated kind of inside of the signature. Am I working at a company, or am I focusing full time on your project? I'm working part time. So do I not try to split that then? Because that's impossible. Recursive modules, they also require the signatures. Signatures also means duplication. Oh, yeah, okay. Hold on. Like, I just want to type the signature first, right? But the signature will need to be duplicated here. Ah. But the signature needs to contain values inside, so the signature itself depends on the other. Can you have, like... signatures that are like functors? OCaml functor signatures. So this is a functor returning set as. I guess you don't do that by including... yeah, because the set as includes the element inside. That's how we know what this is. Yes. One second. You think a camel website uses Flexoki color scheme? This over here? Never heard of Flexoki. Okay. Okay. Maybe I scrap this idea. And we just do a single big recursive shit. Right? Because that's how I did it before too. We look at the old code of the old OCaml version. In the old OCaml version, we had this thing, which is called types. So like a single big thing saying what a value is, what a value type is, and then like all of these things, all of the types in one thing. I mean, it wasn't that big, just 300 lines for everything. Maybe it's not that bad, I don't know. Okay, fine. We delete integer representation, we delete type, we delete value. Instead of all of that, we make a single thing called type, like that. So these three don't exist. Okay. So we just specify here what is a value, right? And what is type, and what is expression, and what is pattern, right? I need these things to be specified. So once again, expression is going to be shape of expression shape, pattern shape expression shape. So we need to specify what is expression shape. This is going to be binding. So which means that I will need to say what a binding is. Okay, it's cool that I don't need to specify what the types are exactly immediately. Oops. Pattern should be pattern shape. Pattern shape is binding, like that, or placeholder. Okay, expression is binding, or constant. Let's actually start with a constant. Constant, a value, or binding, or lambda, closure, whatever, lambda, expression lambda, right? And expression lambda is something, and we have apply of expression apply, and expression apply is something. Right? Binding lambda apply constant. This should be enough, right? For the minimal language. Okay, what's a binding? For the binding, we for now just say name is string. For expression apply, it's just a function, which is expression, and argument, which is expression. Expression lambda is argument, which is a pattern, and body, which is expression. Type is shape, is type shape, and we also have value. Can I say type unused? And like, I just hate the fact that one of the types starts with the keyword type and the other types start with the keyword end. That's just stupid. Why can it not be all the same? Okay, value shape is an int32, or it can be a type of type, right? Let's call it just tie, like that. We can also have a value which is an expression, right? Sure. Maybe we will have patterns as values, although not yet. Let's not worry about this yet. Then value is shape, is of type value shape. We'll have other things later. Type shape is an int32, or it's a type. There you go. Okay. I mean, in this simplistic case, it's not that bad, but this is going to grow, and I was trying to split all of these recursive types into separate modules. I don't know. I think like this is hard. So they all have to live in its own library like that. But all of the types can live in their own library, I guess. That's fine. And then we are going to have a compiler and interpreter. I will try to split those. So what is the dependency that we are going to have? I already drew this before, right? Simplistically. So we have the intermediate representation like this. So the interpreter is supposed to interpret this thing. The compiler is supposed to emit this thing. So they both depend on that. But then at the same time, compiler for running code at compile time will depend on the interpreter too, right? So I guess the simplest one is the interpreter. It's just like we cannot do anything with the interpreter unless we have the compiler, because that's what is actually generating the code that is supposed to be interpreted. But we can start with interpreter, sure. So interpreter depends on now just cast types, I guess. So cast interpreter. Cast interpreter. We need to have type interpreter. Interpreter like state, maybe, you know. Should we have like interpreter state or something? The fact that we cannot have like a record with no fields also is very annoying, Camel. Why do they not allow records with no fields? Anyway, we will have, you know, a scope, which is a scope. We'll see what a scope is. All right. Then we have, like, what do I want to have here? Type scope. We want to have the initialization function. This one gives me a new state. Right? Do I just open the types? I think I might just need to open the types here. Like that. So we can initialize the interpreter, and then I want to be able to evaluate. So evaluate takes evaluate takes should this be unit into state? Sure. should evaluate be a function that takes the interpreter state and takes an expression and converts that expression into a value, right? That's what we want. Function state expression into that. That's all the interpreter is, right? Okay, then let's go into the compiler. Cast compiler will depend on cast types and cast interpreter. Module interpreter is cast interpreter. Okay. So compiler should probably also have state, right? Compiler probably should also have state. And then we have the function initialize unit into state. Can I have let without a value? I cannot. Right? Have val here. Probably not. I could write just a signature though, right? Instead. Yeah, but that's what I should have maybe done. Anyway, so we have initialize, and then I want to be able to compile. So we are going to compile the AST. Compile is a function which takes AST. So this also depends. So the compiler is the thing that depends on the AST, right? Yes. So we make another dependency here, cast AST. I was watching talk on name. You can diff two types A and B to get a tuple containing the difference of their fields. Also has a find types with sync keywords. Should we rewrite in Nim? I heard good things about Nim. Yes, Nim is a good language, I think, but I never tried it. Should we rewrite from scratch in Nim now? So compile is a function that converts an AST into an expression, right? And also takes in the compiler state, right? You're assessing a theory. If you think about a programming language, cool if you will consider rewriting cast in it. Yeah. I remember looking at Nim a long time ago, like 10 years ago or something. It had good features there. I don't know why I never tried it, actually. They were calling it a Nimrod back in the days. Nimrod lang. But then they renamed it just to Nim. Is it like version 1? Oh, it's already version 2, actually. Yeah, last time I looked at it, it was less than version 1. It compiles to C, C++, or JavaScript. I know that they have like AST-based macros. I know that they have model type system with local type inference, tuple generics, and some types. Spacements are groups by indentation. Oh, it's a white space sensitive language, right? Right. I don't know. Maybe if I rage quit or camel, we can try Nim. Nim was supposed to also compile fast, if I remember correctly. So here's the snake game in the browser. Should be able to disable that with the compiler flag. Disable what? White space sensitivity? Cool. What's the reason not to use NimLang? Nim pretends to be slick. Python meets C speed demon with clean syntax and magical metaprogramming, but under the hood it's chaos. Nim's compiler works, sure, but the rest? No, you want LSP support, debuggers? So wait, do they have no LSP? Standard library is a mess. Nim macros are powerful, so powerful that they literally do everything. They heavily rely on macros. My ChatGPT is not reliable anymore. Yeah, I guess. It never was reliable. Okay, so this is the two things that we need to do, right? I need to be able to transform an AST into an expression, and then we transform an expression into a value. And that's how we run code, right? Yeah. Let's do here. Let's start with an interpreter. So this over here, I'm just going to match expression shape with so we have these things. If I have a constant value, then the result is just going to be value. If we have a binding, then we have the scope, right? So bindings, we need to get a value of a variable from the scope. So scope is like, you know, variables, I don't know, bindings, whatever. Let's just have for now a simple one, string map. So a map from string to a value, right? So every thing has that, right? Yeah. So we just say that this should be string map dot find binding name in state scope bindings, right? If we have a lambda, if we have a lambda, then we need to be able to construct values, right? Yes. So value should also be potentially a function. Wait, hold on. I should call it a function, not a lambda. Let's rename this. I cannot rename it. Beautiful. And to make things compile first. Yeah, fn is a good name for it, I guess. So this should be what? Value function value. Yeah. So what is a function value? Function value is... Wait, what is a function value? Well, it's just the function... It's just like an expression lambda, right? We just have an argument in the body like this. So that's the same thing, kind of. It's the same as an expression, right? I think, for now. Okay. Unbound modules. Restart language server. Thank you. Lambda. Now I can rename it to a function. Nice. Expression function. And this should be not a function value, should be a value function then. Yeah, maybe it will be something different later. But yeah, basically we have a function. So we have a value. Yeah, we have this expression here. Right? So what we need to do, we need to pattern match. No, we don't need to pattern match. Hold on. The function expression is just returning me a function, right? Like that. The expected type is value. Yeah, we need to construct a new value where shape is that. Okay, good. And then apply a function to an argument. Is going to be, so in this case, I need to have we need to basically construct a new scope, right? So we need to do pattern match function. Wait, what's a function? A function is an expression. Yeah, so I need to first say that function is evaluate the function, right? Like that. Unbound value eval. Yeah, this is a recursive function. So I have a function which is a value now, not an expression. And I'm going to match f with if it's a function f, then we will continue. And if it's anything else, then we fail. Can only, like, I don't know, expected a function. Whatever. We'll get better error messages later. So the thing that I evaluate to must be a function, which actually, hold on. Do I want to use the generalized AADTs here? I'm not sure that I want, actually. So, like, you know, Camel will have this feature which is called GADT, so that I know that when I evaluate an expression, we can have the expression with the results tied to it. So a value would be a value of this type too. I don't know. I think not. Why not? Because I don't always know this statically, right? Because this expression. But wait, hold on. If I don't know this statically, hold on. Let me read on the GADTs. Camel GADT. So we have, yeah, we can have like this, right? So this is an expression of adding two things together, right? So what this is saying is that adding two things, it's so an int is a constructor that takes an int and returns an integer, right? And add is for some reason just not having any arguments, but it has the type of this function. Okay, sure. And apply, we have a function. Okay. Oh, add is just like creating a function that adds two integers together. Yeah, that makes sense actually. Yeah, and then we evaluate the a term into a, right? So yeah. Yeah. But can I have a term as stored in a thing? In absence of an explicit polymorphic notation, the monomorphic type is inferred for the recursive function. If a recursive call occurs inside that involves an existential GADT type variable, this variable flows to the type of the recursive function and thus escapes its scope in the above example. This happens on the branch FF. So this example doesn't work because this expression has type B into A. Apply F to X, we evaluate F, and then we apply that to evaluated X. This expression has type B into A term, but has an expression was expected of type A. The constructor B would escape its scope. B is an existential type bound by the constructor app, because this is partial function application. Is that it? Or something? No, hold on. It's not partial though, is it? Wait, this and this is the same code. So what's the problem then? Why does this not compile and this compiles? What's the difference here? Oh, because this one is colon and this is using a little bit of a different syntax, right? Because this one... So is this syntax and this syntax actually different, have different meanings? Because this uses some concrete type and this is working for all something. Yeah. Type inverse for GADTs is notoriously hard. Advanced examples. What if I just try to do that? I mean, we can remove that later. So like the type of eval is basically for all A's. If we have an expression that is supposed to evaluate to the type A, right? Then we should have the value of type A, right? So a value is more typed, right? Like normally my values, it was, you know, so this is basically dynamically typed, right? This is basically dynamically typed. Hello, Brainoid. But over here, I can say that if we have an integer value, how do you do this? int32 into int32 value shape. Is that what you do? This makes it a GADT. So a type is a type into type value shape. And fn value fn into value fn value shape. I feel like this is unnecessary though. Kind of. Maybe not for the value shape. But I mean, yes, for the value shape. Hold on. It's a little weird. Feels like I'm just duplicating stuff. I'll try. If it doesn't work, then it doesn't work. And then over here we have a value is shape of a value shape then, right? Like that. So expressions are generic over the result type, like that. Expression shape. So constant is hello Brainoid, how are you doing? Is a value into a expression shape? Is this like, does this mean that this is working for all like that? Is that correct syntax? I guess. So what's the type of a binding though, right? We don't really know the type of the binding is the problem. So want with work and IRL stuff? By work, you mean working on your game? right? So expression function, for example, right? Interesting. So yeah. Huh. You know what? I'm not going to do that. I never use that feature. I don't know how to do it. It's fine. We're going to keep it dynamic here. I'm not even sure if I could use it here. Okay. So no recursion, no GADTs, just that. Okay. So basically, if we're writing this, if I apply a function, then I need to evaluate the function. I need to also evaluate the argument. Right? And then the function must be a function. We can do that. I don't know. Sure. Here. So this is the function. That's not the correct one. This pattern should not be a constructor. The expected type is a value. Yeah, because this should be a value. Okay. So now the problem is, as you can see, we have yeah. So now I have in this module the value and expression with the same names, right? So should we always prefix this? This is expression constant. This is a pattern. This is a type, and this is value, right? That's how you do it in OCaml. You prefix your constructors like that. So this should be expression. This should be value. And this should be value. Oh, you're actually moving to Berlin? Wait, what? Why to Berlin? Like you are moving there to live? All your friends moved to Berlin already? I thought Dan was not in Berlin. I guess I don't really know anything. Oh, Dan is not your IRL friend. Okay, yeah. All right. I was just thinking for some reason that Dan was your best friend. All right. But yeah. This pattern should not be constructed. The expected type is value. What do you mean by that? The value is value. Oh, because I need to, yeah, I need to match value shape. There you go. There you go. So now we have a function, which is a value function. And we have an argument, which is a value. And now we just need to apply it, right? So in order to apply the function, we need to do pattern match. Pattern match, argument, with a function argument. So yeah, so we need to have the function which is called pattern match. Pattern match is a function that takes a value and a pattern and returns the new bindings that we have found there, right? So kind of I need to like modify the scope. So or maybe this should just return the new you know, bindings like that. Maybe if I call these bindings whatever, right? So function value no, a value pattern, and we match pattern shape width. I wish there was like the actually good LSP for OCaml destruct. There we go. So we match this. We have either a placeholder. So if we do a placeholder, it means that I don't generate any bindings, right? So I just say string map empty. Okay, and then if we have a binding like this, then I need to have a string map singleton of a binding name bound to this value. There you go. So this is very simple for now if I only have these two patterns. So we do pattern match, and this is new bindings, right? This is new bindings. In the very end, I will want to evaluate function body, right? And that's what my result is going to be. But before evaluating, I need to construct the new state. So state with new bindings, right? So what should be the new state? New state is so I have this scope. Sure. For now we just have this. So scope is state scope. With bindings being no, let's just do everything. So scope bindings is string map. We need to have a union of the two maps, of the old map and the new map, right? So the old map is state scope bindings. The new map is new bindings. And then the union here is a function, right? So this should be a function from the variable name, the old value, new value, and the value that should be in the union. So function name, old value, new value, into an optional list. So I just say new value, which means that we allow shadowing, right? So basically, if I had an old value, then we just ignore it. We override the old value with the new value here. Okay. Initialize is going to be scope is bindings is string map empty. Good enough for now. So I think this interpreter should work. Then we have the compiler. We can I mean, yeah, let's just do it with the compiler immediately here. Because otherwise, like, in order to test the interpreter, I need to construct the expressions with OCaml code, which I don't want to do, I think. I'm too lazy for that. So in order to compile, so compiler state actually will contain the interpreter, because compiler is an interpreter. Like that. Initialize will say that interpreter is interpreter initialize. The module interpreter is an alias to this which is missing. What do you mean missing? OCaml restart. Why do I need to restart the OCaml LSP? It's stupid. Okay. All right. So over here, in order to compile, we need to match the AST shape. If it is as simple token Then I'm going to match token. Hate the auto-completion here. It doesn't work. Token shape. There you go. Destruct. Match type error, of course. Match. Token shape width. And a file. Unreachable. Module token is cast token. I have that. It's token shape. And a file. Okay. Wait, maybe now that I opened it, it will work. Let's see, token shape. Destruct. Okay, nice, nice. You can do that. Beautiful. Okay, so we have punctuation should be unreachable. A comment should be unreachable. So yeah, this, that, and that should be unreachable. Unreachable, simple AST. No. I just have unreachable. Whatever. So if we have an identifier, then this is going to be compiled into a binding. So yeah, this needs to be an expression. This will return expression binding, where name is identifier. There is no auto-completion. Beautiful. So it should not be a constructor. Expected type is expression. Yes, isn't this an expression? Isn't this an expression? Hello? Why can I not click on this? It's over here. It's opened. Restart OCaml LSP. Like, that's not even the error. This error is fake. It doesn't exist. I hate this. Like, I cannot have underscores here. It doesn't work. It's supposed to, but it doesn't. Fail to do. Like that works. Or no, actually, oh wait, hold on. This actually is. This expression should not be structured. The expression text type is expression. Yes, but this is an expression. Hello? Cast types dot e binding. It's a thing. It's a thing here. What does this error even mean? The expression should not be a constructor. The expected type is expression. What does that even mean? I mean, it means that it doesn't know what this is, right? It doesn't know what this is. And this is a binding. No? That's not what it means. The expression should not be a constructor. The expected type is expression. This... Oh, wait. I understand. I understand. No. I understand. Because this is a shape by the expression. Everything is fine. Everything is fine. There we go. Name is identifier dot raw. Not raw. I want to have, like, for the identifiers the thing. Identifier, like the actual name here, maybe. Let's add to the identifiers name string. Right? And then the lexer is going to say that for now, I'm just going to say that raw end name is the same. But later we will do the raw identifier syntax. Yeah. Okay, so this has been done. String numbers we will say to do for now, or I guess number a raw fuzzy algorithm. Hello. So for the number, I will say that the shape is as a constant, where value is an int, and we will just parse the int here. So value is int var int of string, I guess, raw, something like that. Okay. Comment. Punctuation unreachable. Yes. Okay. This actually, wait, hold on. This actually should work already, right? Kind of. I should be able to compile a single code which contains a constant 1, 2, 3, for example. Let's have a binary now. Let's have a binary. So compiler, or I guess, yes, compiler interpreter command line is going to actually depend on the compiler too. So my main binary is done like this. I split this into modules. This is going to depend on cast interpreter CLI2 now, and then when we have the and if I have the thing that's called eval, so the CLI command eval is going to have an interpreter not run. I will call it eval, I guess. Okay, so over here we will also have eval of cast interpreter CLI args. And if we have eval, good. Then we have eval cast interpreter args parse. Okay. Interpreter CLI. We are going to have something very similar to all of the other CLIs that I have, which is this. But we have not run, instead we have eval, and eval returns. Yeah, eval is just like prints the thing to the terminal, I guess, that we evaluated. Yeah, this is MLI. Just interpreter CLI ML. Okay. Good. Let's copy from the highlight, for example. I don't think I need the lexer here, but I will need the parser. So yeah, so we have the arguments, which has a single path. So I read the source, then I parse the source. No CMI file was found in path from module cast parser. Cast parser, maybe I need to edit as dependency. Yes. So we have a parser parse source like that. So this also depends on default syntax. All right, so now we have the parsed stuff. Then we say that we match parsed AST. If the file was empty, basically, then we say that there was nothing there or something, right? If there was some AST, then we are going to run compile on the AST. So cast compiler. Module compiler is cast compiler. Module interpreter is cast interpreter. Okay, so we say compiler init. This is going to be compiler. And we say compiler compile. Compiler with AST. This is going to be so we compile it into expression like that. Then I say interpreter is interpreter init. And then I say that value is interpreter evaluate. Interpreter expression. And then this is my value. And then we need to print it, right? And then we just need to print. And then we just need to print the so I kind of want to, I guess, open the cast types still. Right? Yeah, so expression here is an expression, the value is a value. I want to say value print value. Vertical bar that I forgot like always. So now how do I print a value? That needs to be done, right? So over here, when I specified all of the types, after that we will have module value is struct print value into so formatter value it like that. So I kind of just do shape print value shape, and we have inside of here module shape, and then we have print which does value shape instead. So this is going to be function fmt into function. So we have value type to do value int32. Like I just wanted any 32 for now, I guess. This is going to be int32 to string, right? And then I say printf percent. Oh no, I can just do percent. Wait, hold on. Is percent d working with an int32? It doesn't, right? Because I expected an int. Yeah. What's an int in OCaml? How is it different from int32? Function fail to do. The value has type int32, but we expected that. We can just do %s, and then we can do int32 to string value, right? Like, that's fine. Okay. The implementation of this does not match the interface. Wait, really? Value eval. Okay, yeah, because this should be not run, this should be eval, basically. I will have a separate run, which does a little bit different stuff. Okay, so now we should be able to say something like this. Cast. We need to say cast eval examples hello this, right? So this will have a to do. By the way, can I have the stack trace for that? Exception this fail format, kind of. You know, I'm just printing the thing, but I also want to print the stack trace. So print exception stack trace backtrace, print backtrace to the stdr. Here and here, I think. So inside of the compile. So like this to do, obviously, right? I wish the stack trace was more precise though, but it's not. For some reason. Okay, so if I have a simple example, so we here's the idea, right? We make a new example called 123.ks, and this will just have 123, right? This is just a single thing, which is 123. So if I want to evaluate the 123, it will actually understand that it's 123 now. Okay, good. That's the beginning. That's the beginning. Next, we want to actually be able to evaluate the hello world, right? Hello world is more difficult because I don't want to implement the use yet. The std star. This requires a macro, so we just have the this print hello. We can do cast eval. I just call this file test interpreter. So for the things that we have already implemented basically in the interpreter. 1, 2, 3, that's the only thing. Okay, compiler. Now there's going to be let's actually have strings too, right? Strings. Yes. So let's, yeah, hold on. Let me commit this thing first. Okay. So now I'm going to have a new thing, a new type of a value, which is going to be a string. Like that. Yes. Why is this red? Unused open. Why is it red? It's a warning, right? Oh, because there is more red stuff here. Like it highlights the warnings as errors if there are other errors in the file. Yeah, I remember that. If we have a string value, then we just go into %s value here. Okay. So this means that in the example, I can say 1, 2, 3 as a string like that, right? And it's going to have a to do here in the interpreter, in the compile, still a to do. Oh yeah, I didn't do it as. So this should give me a new expression, constant of a string where value is the contents of the string, like this. Okay, there we go. So now we have the 1, 2, 3 as a string. So we have strings and numbers. Next, we want to be able to have we want to be able to have a, let's have like I feel like I can have a native function print, right? Like what I want is something like print hello world, right? We want this to work. In this case, print is going to be hard-coded in the interpreter as a native thing for now. So the values, once again, values. There's going to be a new thing which is called so we have a function, but we also have function value native function. Native function. So what's a native function? A native function is just having the implementation, which is basically having the argument, which is a value, and then it returns a new value, right? So that's all that it is. Could have a name here, an addition later. Actually, let's have a name immediately. Name string. Yeah. So when I want to print a native function f, then I'm going to print name. I'm just going to say native that. Yeah, let's also have some colors here when I'm printing. The string is going to be green. The number is going to be Alec. The native function is going to be I don't know. Also just italic, whatever. Okay, so in the interpreter, I'm going to hard code. So when I initialize, right, these bindings, we are going to have string map of list. Built-ins. Right, so built-ins is a list where print is a function, native function with name print. You know what? How would I just say native function print, and then function value into that, where native function name impl is name and native function name impl that. So in this case, I'm going to match value shape with value string, then value string s. Then we just do print %s s. If it's anything else, fail, print expected a string, right? Oh, and then we need to return value, right? But the value that we return is always just going to be, so we need to have a value unit, a unit value, yes. So we have a new value, which is unit. Yeah. There we go. The pattern match is not exhaustive over here. If we have a value unit, then we print it as that. Yeah, this is value where shape is unit. That string map of list built-ins. The expression has type string map t, but the expression will express of type binding is value string map. Type value shape is not compatible. Yes, because this also should be value shape is that. The variant expression is type. Oh, okay. This should return string and value. Okay, there we go. Okay. So now we have the compiler having it to do over here, right? So we have a complex thing, which is saying, now that we have this complex thing. So complex AST has the rule that was used to construct this, the children ASTs, and that should be enough for me. So we have rule, and we have children, and the parts I don't care about. We'll do that. Now we're going to match rule name with. So specifically for, I mean, we could actually have print as a keyword kind of instead, but yeah, never mind. So we have the thing that is called apply, right? So in the syntax currently, it is called apply. I'm pretty sure. So if it is apply, if it is anything else, then I'm going to fail to do syntax, to do compile syntax rule rule name. This is in parentheses. Okay. So we have apply, then I need to have an expression which is expression apply, where function and argument needs to be figured out, right? So what's a function and an argument? So function is children. So children is a tuple. So we need to have a tuple get named function in children. And then arg is tuple get named argument in children. And then we say that function is so this is going to be a recursive compiler, right? So we compile the function, then we compile the argument, and then we create the apply here. Okay, I think this actually might already work. It says expected function over here, because f is not a function. Okay, yeah, because this now actually is a native function, right? So I'm not calling a function, I'm calling a native function. A native function f. In this case, I just call a function implementation with the argument. And that's all that I need. Yeah. So in fact, all of these, I'm going to just match. Oops. Sorry. So if it's a normal function, then we do all of that. But if it's a native function, then we just call the native implementation. Okay, there we go. Hello world, it works. We have a hello world. It's working. Nice. Okay. What else do we do really quick? We can do some... you know what? Let me first do some stuff. So like over here, the rule name is not apply, right? So in the old version, I was calling this built-in macros, but I want this to be called like core. So I want to like specify the core syntax, right? So applies the core syntax. So I think something like this. If it's core apply, then it's going to be that. So let's go to the default syntax. Rules. So apply, this is going to be called instead, this is going to instead be called core apply. I'm going to call all of them cores for now. So core is something that is implemented in the compiler. Other things can be implemented through the macros. And we just use the naming convention here for it. Can I do it without naming convention? The pipe should not be really core. But yeah. And like something like math should not be core, because math just corresponds to me calling a function. This will start failing the tests because I expected apply, but I actually go to the core apply in the tests now. I don't want to have this anymore. Maybe I have a separate syntax just for tests. I don't know. No, it's fine. Let's just fix the tests then. test of the parser. I mean, I think I just strip the prefix of the core when I'm testing the things. You know, like over here. Hello, Nerdsoul. I feel like over here, the actual name of the rule that rule name is basically going to be rule string strip prefix of the core option value, where default is just the original rule name. You know, and then we use that one, and then my tests are going to still work, right? So like, yeah, I just, for the sake of tests, the core prefix is going to be stripped. Hello, Nerdsoul. We already have a hello world working. So the all the things that I implemented in the compiler so far is the core is like applying a function and having identifiers, having strings, and having numbers. Right. Prefix core syntax with core. Okay, we can pretend that some of the syntax is core right now. One of the things that I want to do though, so like, so core syntax is something similar to the built-ins of the interpreter, right? So the interpreter has some built-ins like print function, right? And the compiler built-ins are these core syntaxes, basically. I want these to be somehow split. No, maybe not even in a single package, but at least in a different module. So let's have interpreter built-ins here. Can I do that? Can I do that? Yeah, I guess I can. Built-ins, like that. Okay, and similarly to that, I want to extract all of the core syntax of the compiler into its own module. So compiler of the core syntax, like that is going to be over here. But wait, hold on. But the core syntax potentially needs to recursively compile here, right? Yeah. Let me see. What do I have here? I want to compile core syntax, right? What should that be? We basically need to have a map from a string like this, right? Core syntax. You know, core. I don't know, handlers. I think I need to have like a string map from a string, which is like apply, into the actual function, which takes an AST, which takes a complex AST like that. So AST complex. So a function, I don't know, let's call it handler. So type handler is AST complex into an expression. Right? And then we just say string map of list. And then we will have like, you know, apply is you know, yeah, let's have apply. Uh let's just have apply here, I guess. So apply is apply and the handler. You know, so it's like the name of it plus the handler. That's what I want. It's apply plus a function AST into to do something like that. So in this case, that's what we need. That's what we need here. So the AST is that, right? So we have children. And everything else I can ignore. But this needs to call the compiler inside, right? How do I call the compiler inside of this? It means that this has also so this is like recursive, right? I can make the compile be another argument to this. So handler takes in the function that is specifying how to compile inner expressions, right? But I might potentially want, when defining the core syntax, to modify the state of the compiler. So I need to have state of the compiler here. Yes. Oh my god. Like once again, I just I don't know. It's easier if I scrap the idea of trying to split this into modules. Because this now I need this state, the type of this to be in its own module, right? Yeah, sure. State T. Can I have another state that type T is that, where we have that. So compiler depends on the state and on the core syntax, right? Yeah, so we have the rule name. Let's see here. Let's see here. Before doing that, I will say match rule name into string strip prefix, where prefix is core. So if it's not a core syntax, then we do that. But if it is a core syntax, then I will try to find this in the cores, right? So core syntax, whatever. This doesn't compile yet, so I cannot have autocomplete, of course, right? Or can I? Handlers? Yeah, because it's missing, of course. I guess like compile should be a recursive thing. So a handler takes the recursive thing to the as an argument. Compile takes the like compiler, which is like state t, ast t into expression, right? Unbound value state. Yes, because this also still needs to know the current state of the compiler too. Right? So compile, current state, and this. And that way I can do it recursively. Okay. Can I have this being named? I like this being named. Compile and state. So we have the core syntax handlers. Then I need to string map find the name there. Right? So this is a handler. And then I need to call the handler with the with compile being compile. So this is literally the recursive function. And then state being state. And the thing that I'm compiling is this. I feel like I only need the children though here. Maybe I just need the children here to be passed as an argument. Where is the syntax error? Once again, there is a syntax error that I don't see. Where? Line 25. As. Okay, there we go. So handler should actually take not the complex, but it should take AST tuple. Right? So this is just the children. Like that. Does that work? Okay, hello world still works. So I have kind of extracted it. Good. Extract interpreter. Built-ins and compiler core syntax. Okay. Nice. So now we can have other core syntaxes, right? Now we can have other core syntaxes. For example, for now, I can say something. I can even implement the addition, right? So add. No. We say let add be that. Apply add. Add string and handler. So add has the get unnamed 0 and get unnamed 1 in children. So this is A and this is B. Right? I can implement it as a core syntax for now instead of a macro. So I will return though shape, which is I will although apply where the function is going to be constant of a value, which is a native function. Is this not correct syntax? Why is this not correct syntax? Because this over here. Name is add. Right. Okay, implementation of this. Let's extract this add. So I will say that add is a value, which is that. A native function with implementation being function. No, not function. Function argument. Oh wait, but since this is, yeah, this should be a function. So this means that I need to have tuples as values too now, right? Yeah. Okay, we need to do that immediately. To do. Sure. So I need to make a tuple of these things. So I need to have a new expression. Tuple. Expression tuple. What are we doing with OCaml? I'm making a programming language. Hello. Expression tuple is just just going to have this tuple expression tuple. Could just have it as an alias, but I feel like I will be adding more fields to this stuff. I'm rewriting my programming language into OCaml because of the compile times of Rust being slow. And OCaml is supposed to be compiled instantly. Right? Right? But Rust? Yeah. I like Rust more. But, yeah. I don't know. I don't know. I can see doing another rewrite and then back into Rust. And then we're going to go back into OCaml and then back into Rust and then back into OCaml. Eventually it is going to be done though. What's the issue with the compile times? Just general debug builds while working on it? No, debug builds, yes. The debug build takes a minute to compile. I'm supposed to split the things into crates and it's not that easy. Like even in OCaml here, I was literally doing that right a second ago. So here's the problem, you know? Here's the problem. We have a language which it doesn't matter if it's crane, lift, or mold. It's not the linker, it's the type checking in Rust that was taking a long time. The problem is that I have like a huge crate, kind of. I mean, I could work on Rust trying to improve the speeds, but it's also like it's also a lot of work. I feel like I would need to rewrite from scratch anyway. But we have in this language values, types, and expressions. Expression is the compiled code. Value is just a value. Type is a type of a value. And the thing is, we are treating types as values, so the types depend on the value. No, not the type. The value depends on the type, because the value can be a type, right? But also, expression can contain a constant, which means that we have this dependency, right? But at the same time, an expression can also be a part of the value, because, for example, to represent a function as a value, we need to represent its body. so that we can evaluate it later. So we have this dependency, and then the type is similarly having a dependency on the expression potentially. So which means that this is a cyclic stuff which cannot be split very easily into crates in Rust or into modules in OCaml. It's difficult. You tried it with next-gen trade solver. No, I have not tried that. Is it faster? I'm not going back to Rust, not yet at least. I'm not rage quitting OCaml just yet. Maybe in the future we can pick up the old code and keep working on that. I can always do that. Not sure, but you are interested in trying to improve the compile times. You can just clone the thing and compile it. There are some things that I did already, like, so there we go. We go to temp cast here. This is the old code written in Rust, right? So let's say that I'm going to do cargo clean. Like obviously it depends on what part of cast am I touching, right? But right now there is this single huge crate, right? So this crate contains compiler, interpreter, the types, like JavaScript transpiler. There's a bunch of things here. I have a couple smaller crates, but mostly it's this single crate that can do everything right now. So I have this thing which says check compile times, right? So I can just run that, check compile times. We're going to compile this thing. So I'm using the I'm using these time passes, which is going to tell me the timings of every like step in building the thing, right? So we're going to wait for it here. Just wait for it. It takes about a minute. All right. Over here, I'm cleaning all of my own crates. So all of the crates in my thing, right? Obviously, I don't always do that. Sometimes we have incremental builds, but even then, like this crate just takes too much, and it will be rebuilt if I touch anything over there. You've messed around with optimized compile times before? Yeah, like I have a lot of async code. I have a lot of generic code. So yeah, like if you want to write Rust that is compiling fast, you need to write it in a very specific way, and I have not been doing that. It is still compiling. And I am compiling build, so this is a normal build, this is not a release build, this is a debug one. For the debug though, I do have, no, I actually don't have. Yeah, it's when I'm working on the Linksider, I have the optimization of dependencies, but for this one I actually don't. This is the repo, yes. I'm just going to show you this here real quick once it compiles. Can you please stop compiling? It is still compiling. This is slow. Okay, done. Okay. So I can go and try to edit the timings here. So, oh, wait, it's because I was compiling some dependencies still. Yeah, it's fine, it's fine. The dependencies, they don't matter because we do it only once, right? But you can see over here, I'm compiling cast, right? So this is the crate, the main crate that I'm trying to compile. And it says over here, type checking the crate. Type checking the crate takes 20 seconds. Monomorphization collector graph walk. So monomorphization takes another 20 seconds. Generating crate metadata takes 20 seconds. All right. So that's my problem. And this just this single crate is compiling in 60 seconds. All right. Yeah, that's the problem. And then there is also this target cargo timings. So this is all the timings, right? So all of the dependencies All of the dependencies were compiled in 50 seconds, but every single dependency is like really fast to compile, right? And then this is my crate, which is like this. Try the flag. Okay, how do we try that? Let's try that, sure. I don't think I will go back to Rust though anyway. Not yet. Again. So I need to just do a Z, another Z. Next, solver is globally. Is this part of the Rust flags or... Or part of the, like, to the cargo that I build? I mean, this is part of the Rust flags indeed already. Make sure you're using a very recent version though. I'm using nightly, yes. Cargo version. This is nightly from the June 16th. Should be good, right? This is, I guess this is also going to recompile everything from scratch though, because I changed the Rust flags. Okay, we'll wait for this. And in the meantime, I'm going to keep working on the OCaml. Some record fields are undefined. Arg. Arg. Yeah, so argument is going to be expression tuple where have that. So the arguments of the addition function is going to be a tuple. Tuple make. Yeah, I guess tuple make is what I want. I want to make a tuple with two arguments, no named arguments, just two unnamed arguments, which is going to be A and B. But A and B should be expressions, which means that I need to compile them. So A is compile state A, and B is compile state B. Right? There you go. Now I have a native, yeah, so we have a tuple of expression, then we will have a tuple of a value. Value tuple is value tuple like that. If I want to print it, it's going to have to do for now. But over here we have an argument. This must be a tuple. So I'm going to match arg with fail expected tuple. If this was a tuple, then we say that A is tuple get unnamed 0. B is tuple get unnamed 1. And then we say, so now I need to see, yeah, now I need to match A shape and B shape. You should learn some OCaml soon. You have a uni classes that uses it. If you like Rust, I think, I don't know. I know that some people like OCaml more than Rust, but I hate it. And I'm still writing it. Like, I don't know. I feel like Rust is better. But yeah. I mean, there are certain things that are better in OCaml. For example, you can have like recursive closures that you cannot do in Rust, right? You need to like wrap it in a function. There is garbage collector here, which makes some things easier, but I don't think that's a big deal unless you are not very familiar with the borrow checker. The other uni classes forces me to use Java, so I think OCaml is improvement over that. No, OCaml, I mean, it depends, you know. OCaml is not always an improvement over Java, because at least Java like language server usually works. You work with an IDE in Java, and your IDE is like auto-completing the things for you. It can rename things for you, right? That doesn't always work in OCaml. It sucks. It sucks. I guess Java is the language that has like maybe, I don't know if it's the best tooling, but it's like the best IDE support at least, right? Maybe. Is there a language with better IDE support than Java? You hate Java passionately? I don't know. I hate all the languages, so I don't know. At this point, I don't know. I mean, I would use Rust if it was not the compile times. Rust is the best. Haskell, if not, I mean, I hate Haskell too. I hate OCaml. I hate Java. I hate C++. I hate everything. Running Java from terminal is something I still don't know how to do. Don't worry about it. You don't need to run Java from command line, do you? No longer, thankfully. All right. Okay, so if I'm trying to add an int a and an int b, then I will return an int a plus b. Right? That's what we want. Match with, of course. And this needs to be in a parentheses like that. Okay. The variant. Okay, this needs to be not int. This needs to be v underscore. The expression should not be constructed. The exception is value. Shape is that. Oh, plus doesn't work, right? Plus doesn't work because plus works for ints, not for int32s, of course. We need to do over here int32.add ab. Of course, of course. It's fine. So now I can add, I think. Let's have a test interpreter. Can I print? Can I not print? Let's comment this out. Wait, is this not correct cast? 2 plus 2. Why does this do that? Because we have comments attached to this AST. Is that why? We have like plus dot or something. Not in OCaml. I mean, I can say that let plus be int32.plus. I can override the thing, right? They just have a plus. You know, I can say something like that. Let plus be int32.add, right? And then I can say a plus b. Then this works. So I temporarily override the plus operator to be specifically working with integers. Like we don't have generics. We don't have traits in OCaml. That's the worst part of it, I think. Maybe. Okay, if I have an expression tuple and I want to evaluate that. Expression tuple is a value tuple where we have tuple.map. We don't have a map here though, right? Yeah, we don't have a map. What would be the difference between overwriting and overriding? Overriding, I guess, keeps the old. Overwriting is like shadowing, right? you lose access to the previously defined thing. And overriding, you keep both, right? That's the difference. Tuple, map, function, expression into into eval state map using eval state, I guess. Shape. Okay, so we need to have a function called tuple map. Let's have it. Let's have that. Map is a map is a thing. So we have for all a and b's. If we have a function from a into b, and we have a tuple of a's, then we can have a tuple of b's, right? There you go. Yes. Okay. So this is a function f tuple into a new tuple. Have unnamed b. Unnamed, named order. Unnamed is named list map f. Then named order rev is the old named order, and then named is named order rev list rev. A list map function name that current value is string map find name named, and we say name and current followed with f, and then we say string map of list. There you go. Hi Justice. Oh, I was just going to say that my name is not Justice, but you were greeting someone else before greeting me. I see. All right. It's good that you guys know each other. Where did you guys meet? On another stream? Please don't get jealous. But the value unnamed has type A array. Oh, it's not array, it's an array. Wait, do we have array map? Yeah, we do. Okay, nice, good. Good. Justice in Janet's stream the other day. Nice. Do you guys like Lisps, right? I never written a Lisp. Should I rewrite cast into a Lisp? Nah. Tuple. There we go. Warning 33. Okay. Eval 4. Hold on. 2 plus 2 worked. We have 2 plus 2 that is working. Okay, good. You like functional programming? I'm wondering if like my language is going to actually be called functional. Like, I don't know. Is Rust functional programming language? Probably not, right? If 2 plus 2 works, we can make a game, right? Yeah. You don't like Lisp, but you just don't discriminate based on the bad language choices. What's the good language? What's a good language? I think there is no good languages. Otherwise, I wouldn't be making my own one, right? Is arithmetic Turing complete? Okay. Let's stop here for now. Or no, hold on. I want to do this. I want to change this example. We still want hello world, and then I want a semicolon, and then a 2 plus 2 like this. So this should print hello world, but evaluate to 2 plus 2, right? Because yeah. So this means that I need to have exception not found over here. The core syntax is not found, right? Let's try that. Find opt first of all, and then I'm going to have let handler is match handler with some handler, then handler, and then none, then fail. Is there a short syntax for this so that I don't specify handler like 10 times? I want basically an unwrap or else, right? But yeah, I guess we just do that. Actually, we just do option or else. Option or else. Yes. Option or else. Function fail. There we go. I made this myself. They don't have it in the standard library of OCaml. So we have I want to fail, saying that core there is no core syntax name. This should be called like unwrap or else. I'm just going to use the Rust's thing. Yes, let unwrap or else is going to be unit into a option into a. There we go. I'd argue that Rust allows you to program in a functional style. Yes, but do you do that when writing Rust, really? So I'm making a language with an effect system. When you are writing a when you're writing code like that, it's no longer functional style, I feel like, right? Or is it? I don't know. If you are writing Haskell and you're inside of a do notation, is that a code functional, or is that like, because that's imperative code that you're writing inside there basically, right? Is the functional code only like the pure code in Haskell, or is the other code can also be called functional? But then what's the difference between the do notation in Haskell and like your normal code in JavaScript? Can you explain lifetime looking thing? This is a generic. This is a generic type. This in Rust is called like unwrap. This is basically function unwrap or else, which is generic over a, right? Which takes the arguments, which are you know, unit into a. You know, in Rust you say function unit into a, right? And then you have the option. I guess in Rust you usually call it T, not A, right? So you say this option T, and then from this you return T, right? And we don't have methods, we just have freestanding functions. In Rust this would also be a method on an option, right? Yeah, just a syntax that you don't know. That's simple. So before the dot is all the generic arguments. I can also skip this, it can automatically infer this, but I prefer writing that explicitly. There you go. That's the difference. There is no core syntax then. Okay, so then is the syntax of a semicolon here. So let's do that. Let's implement it. Core syntax. Yeah, add, we will remove that. To do remove. Add is here temporarily. So for now we only have apply basically, and then we are also going to have then. So a then is a thing which does A and then returns B basically, you know? So we have get unnamed 0, get unnamed 1. So this is A and then B, right? So this is basically the syntax that corresponds to A semicolon B. Now we have now we compile A, and then we compile B, and then I say that we have expression then A and expression then A B. Let's just do that for now. Syntax error, let extension with punning is expected. Oh, then is a keyword, of course. We do then underscore. You don't use then this. I think that the other libraries use underscores. You can do that? I guess you can use that. I don't know. What do you call this? An apostrophe? Or what? Our hashtag then? Yeah. They don't have the raw... Wait, can you do that? No, you cannot. You can do it only in the end. I guess this is the alternative of the raw identifier. Sure. Okay, so we need to have another thing which is called e then of expression then. Expression then is A expression and B expression. Maybe later I will have a list. Actually, yeah. Let's for now just have a 2 here. Fine. Files make inconsistent assumptions over interface cast types. What? This pattern matching is not exhaustive. When I evaluate expression, then A and B, then I just need to evaluate A, evaluate A, and then I need to evaluate B. That's all that is needed here. And I'm going to ignore the result of A, right? Or we can make sure that this is a unit, but we don't care for now. Okay, there we go. So I print hello world and then we return 4. That works. Nice. That sounds like an awful error to debug. That was a fake error. It didn't even exist in real life. The LSP in OCaml is bad. It shows you fake errors. Can you do add then? No. Not in OCaml. Right? Wait, yeah, add is the operator for concatenating lists for whatever reason. So if you have like list of 1 and then you do add list 2, you get as a result the list of 1 and 2. Sounds very random. I don't know why. Yeah, this language is weird. But it's fine. It's at least it compiles fast and it has a good enough type system. All right. Good. More. What do I do now? I want to change some things here. So first of all, I'm saying this: get named, get unnamed. This is not exactly what I want. I want to write this in a better way. So I want to have a tuple. Wait, can I even have the alternative of the thing that I had in Rust here? So in Rust, I would say something like this. Let I want to have tuple into tuple into, you know, I specify what are the unnamed fields that I expect here, what are the named fields, so I expect f and arg here, right? So this function would return in Rust an array with 0 elements of unnamed and the array with exactly 2 elements here. But we cannot have that. Here's what I have in Rust. Tuple. Like, so in Rust I would be able to say like let ABC be tuple into unnamed. So this uses the const generics. We cannot do that in OCaml, right? I mean, wait, can I even do in OCaml something like this? Let ABC be 1, 2, 3. Can I even do that? I cannot because this pattern matching is not exhaustive, right? Because this is just a list. I mean, we use semicolons, but anyway. 1, 2, 3. This still doesn't work, right? Because the pattern matching is not exhaustive. So what do you do for that? There is no let else in OCaml either, which is annoying. We can have a let. Wait, how does let star works again? Hold on. Let star. Over here. This is just option bind. A into B option. Yeah. Okay. All right. Hold on. But I don't want to have the custom operator like that. That's annoying. Okay. So for this to be done, this must be a tuple and not a list. But how do I make this? That's impossible to represent in OCaml, is it? Like the problem here is that I might, like I need to check that there are no other arguments so that I don't make a bug of ignoring those, right? I mean, I can have a separate one, like tuple, tuple check, check structure or something. Tuple check. Like, I want to check that the tuple has a like 0 unnamed ones, and the named arguments are f and argument. I can do that, for example. Right? And then this this one would like throw an exception if this is not this the actual type here. But then I can forget, because now it's in 2 places instead of in 1 place. I can forget. Right? So instead I want to have a function tuple tuple unwrap or something. I don't know how to call it. Tuple unwrap. So I expect this, I expect that, and I want to then say that we have I don't know. I feel like we can just do this. F and arg, like all of this is here, all in the single list. But then there is no let else. What's the alternative of let else in OCaml? There is no direct equivalent. Just use Rust. But since we're punishing ourselves with OCaml, here's how we can approximate it. We can have a pattern match with an early return. Or we can have this thing there. Yeah, I guess like we do that. It just introduces a new level of nestiness, which is annoying, you know? So I want to like basically match this with f and arg, then we do like all the other stuff, and if it is anything else, then I say unreachable. Something like that. And then why is there a syntax error? Because of this bracket, which needs to be over here. Yeah, the problem with this is that there's this two unneeded levels of indentation now. I mean, it's better than nothing. ChatGPT sounds like the average Twitch user. Why not Rust? Yeah. Yeah. OCaml is not expressive enough to do this properly, right? Like I can have specifically the unwrap2 function, which is returning like a tuple of 2 elements, because we don't have the lists of concrete things. So I would have unwrap2, unwrap3, unwrap4, unwrap5. Maybe this is fine. You know, let's just do unwrap2, and then I will say let f and arg is unwrap2. Yeah, you know what? Let's do that. I like that. It's annoying, but it's better than returning a list and then matching against it. We just have like 10 functions depending on the amount of arguments that I want to unwrap. Fine. So yeah, basically we have first of all I have the generic function unwrap, which has a if I have a tuple, I want to have and it returns a list. And actually, so that this works with piping, we need to have these arguments first, which is the amount of unnamed arguments. unnamed is an integer, and then named is a string list, like that. That's what I want. So we would be able to write this as children into unwrap2 like that. That's what I want. So this is unnamed, and this is named, you know? Yeah. Can we have a argument that is optionally named? I don't think we can, right? So it's either named or unnamed, you know, Camel. That's fine. Okay, let's do the generic one that's working with the lists first. So function unnamed named tuple. I'm going to say that if tuple unnamed length tuple unnamed list length is not equal to unnamed, then fail. Acted this unnamed fields got this many. Named actual named. Semicolon. Then we say if string set of list named, let named be this, and then I say that actual no. Yeah, then we do actual named is string map. Can I have like just the keys of the string map? There is no existing things like that. There's an iterator though, or I guess not map. To list, I guess, right? That's what we want. Every compiler interpreter runtime existent has at least one place where there's do with 1, do with 2, do with 3. Yeah. Well, I mean, before Rust had const generics, this would also be done like with macros instead, I guess, or be painful like that with an exception that I'm going to do in a second. There are still places where you do macros for tuples for like specific things, specific arities in Rust. String map. Okay, let's just say it to list list map key. So I just care about the keys here, right? And then I just say that if named string set dot equal named and actual named. If they're not equal, then I'm going to fail another exception. Failed. Expected. Named fields. String set. I need to like print it here. print. Yeah, sure. I mean, I have a list print. I will add a print here. String set print. String print. Normal print is printing that. Yeah, print dbg. Named. Got string set print string print dbg actual named. What is string set print? Let print is a function from formatter. To set the unit. And then how do I print a thing which is t into format into unit matter. So yeah, this is function print element fmt set into, I think I just do list print element fmt to list set. Oh, they just call it lt here, right? So not tt, lt. There we go. That should be fine. Function should have type string. Hold on. It's because I didn't return yet, right? This is not correct syntax. Okay, where's my syntax error? OCaml, show me where my syntax error is, please. Please. It's in line 122 over here. Did I forget an in? No, I did not forget an in. What if I comment this out? Line 122. I don't see the syntax error here. Am I blind? Maybe this? Okay, that was it. Okay, now what are you saying? The function should have type name. Oh, it should, yeah, named. Name. Okay, good. Field access tuple unnamed has type a array. Array length. But actual unnamed. %d. String map to list. Got a. Yeah, you know what? Actually, this one is going to be not string set. We're expecting this. It's going to be the set I've expected, but the actual ones is going to be the tuple named order ref. Yeah. Instead of list. That makes sense. This question has type string list. There you go. Yeah, I want over here to just say instead list print string print debug tuple named order ref. Let's do that. Do you like OCaml after all you have done with it? No, I don't like OCaml. But there's I don't know. Rust is better. But I'm going to keep writing OCaml. We just need to keep suffering through it. Eventually it will be good, right? Right? Okay, so over here I return tuple unnamed array to list. Then I would say list append this one to the named ones. Okay, so we have named. But no. This should be like named set. Yeah, you know what? I will do a list here too. I will print the named. I'm just comparing the sets. Yeah. Named. So I say named into list. Named into list. Map function name. I return string map find name in tuple named. Okay, I think this is what we need. So this is the actual implementation, and this is just the checks. A couple of checks of the fact that the structure matches the expected one. Okay, so then we have the function unwrap2, which is having a named int into named string list, a tuple. So this should return a and a, right? So I'm going to match. Match is going to be equal to function unnamed named tuple. Then we match wrap named tuple with, if this is A and B, then we return A and B. If it's anything else, then we say fail. Let's just say invalid argument actually in this case, because you are supposed to provide the correct number of things here. You seem very competent developing with OCaml. I mean, the language is simple. It's like, it's not like the language is simple, and that's why it's a bad language. Same reasons why I hate Go, same reason why I hate Zig, and same reason why I hate all the other languages. It's too simple. It doesn't allow me to write the code in a short readable code. It becomes unreadable because of the amount of what do you call it? The boilerplate that you have to write. Well, it's not that bad compared to some languages, but when comparing OCaml and Rust, then Rust is clearly winning. Even with all of the boilerplate that you write in Rust, with like explicit boxing and explicit like a bunch of other things. I feel like the amount of time that you spend fighting the borrow checker is less time than writing the boilerplate in OCaml. But yeah, maybe that's just me, you know. I'm just a hater. I'm hating everything. So unwrap 3 just does the 3. If I will need that, I will do that. Let's also have that unwrap single unnamed is going to be just an easier one. So this one says that unnamed is 1 and named is an empty list. So this should be unreachable. This returns A. And unwrap single named would be me having a string which is the name. So we do 0 and named is name. Like that. Okay, single. That. Let's also make sure that sometimes I want an empty one. Let's just say assert empty. It's a function tuple into ignore unwrap with unnamed being 0 and named empty list. Yeah. Traitor. Spike says traitor. Doesn't matter if you're a hatter. You always keep trying new things. Yeah, but I should stop trying new things, right? I should just make sure that my language works. Traitor. What do you mean, Spike traitor? Did I be... who did I betray? Did I betray Rust? And because I'm writing OCaml. Can you please make it so that my old Rust code compiles in less than a second? Then I will go back to Rust. All right. So I'm using these functions in the interpreter. Tuple dot. No, not in the interpreter, in the compiler. Oh, well, no, in the interpreter built-ins, probably. No, never mind. In the interpreter, in the compiler core. Yeah, so now we say unwrap 2 here. Yeah, so instead of saying this, get unnamed 0, get unnamed 1, I will just say that let A and B is tuple unwrap unnamed 2. How about that? Children. We'll do that. Let's have these functions too. I mean, usually it's unwrap. This is like generic unwrap too, right? But I want to also have unwrap unnamed 2. Let's just say that unwrap unnamed 2 is unwrap 2 unnamed 2 named empty list. Do that. What is there? Is this unbound value named? Oh, yeah, there we go. Type contains non-generalizable types. This is annoying. Oh. Tuple. If I do that, then it's going to be fine. Yeah, this language is weird. Unwrap named to. Tuple. Names. Names. 0. Okay. There you go, there we go. Unwrap 3, 3, 3. I mean, usually it's just 2, 3, or 1. Or 0. So we have those options. Okay, and then over here I do the same. Unwrap 2 unnamed. Over here we say unwrap 2 unnamed. What are you saying, AST? Are you stupid? Is this language stupid? Why is A? Oh, because it's not children. It's tuple, of course. That's why. That's me stupid. Okay, good. Tuple unwrap. Nice. Unwrap single unnamed, unwrap unnamed 2, unwrap unnamed 3. That's what I did, yes. Yes. So a single unnamed will be unwrapped, for example, if I have in this example code, if I have 2 plus 2 plus 2 plus 2, right? This should still work. This should return 6. Now if I make this to be in parentheses, this will not work. There is no core syntax scope, so I need to provide a syntax for scope. And scope is very simple syntax, right? Scope is very simple syntax. Scope. Scope has a unwrap single unnamed. So we have a single expression inside the things. And so this is the inner expression. Whatever, expression. Well, I mean, actually, I will have an expression scope because it needs to, once we have like actual variables, the variables should be scoped to these scopes, right? So I don't just compile the inner expression and say that this is the thing. I will actually have an expression scope with this expression being inside. So we need to have an expression scope of expression scope. Expression scope is expression. And this expression should be compiled. So expression is compile expression like that. All right. File state. What? No. This pattern match is not exhaustive. So if I am trying to evaluate expression scope, then all I do is I just call the evaluation recursively for now. We don't actually open a new scope yet. We don't implement that for now. So there we go. Now we have 6. Okay, good. Good. Let's, you know what? Let's have this. Let make bin op. name and f is, let me do that. I want to over here make binop. So the function would be this. That's what I want. No? Function that make binop with the name being yes. Instead of here having add, we just have a name. We say AB. So we have apply. Pattern shape. What? No. This thing returns expression. Okay, but over here we say not match AB, we just call function f with a and b. There you go. So now I can have this binary operator. So this function is the from two values into value. But it, okay. I hate this. Expected type is value. Oh, wait, no, that's right. It should be value shape, actually. Yeah, let's just do value shape here like that. So this should be shape is that. That good? A has type value. Yeah. A shape, B shape. There we go. You just canceled your monthly donations to Vax3 that have been going on since 2022. Hey man, remembered you need to activate Linux. Thank me later for the reminder. Yeah, thank you for the reminder. I just I cannot do it right now. I'm too busy making a programming language. Cannot have a break. I'm too addicted. Okay, anyway, what I want to do, like just for now, you know? Just for now. Let core is apply, then, and scope. But then this should be core and to do remove, you know? To do remove is this. Add. There you go. I won't have add, I won't have sub, I won't have mal, I won't have div. Let's just have all the math here. For now, I will just say sub. I say let plus be sub. Beautiful, right? And it's just going to work. Mal. Div. This way we can have all of the maths. Right? Div divide plus is a star, sub is a minus. Okay, let's go. Let's try to do some math now. So if I say 2 plus 2 times 2, it's going to be 6. 2 times 3, it's going to be 8. Divide by 3, that's 4. That's correct, right? This runs based on AST. So I call this intermediate representation, not AST, but like once again, maybe I should rename the things. Zaka. I remember we were like arguing about that earlier. But my intermediate representation is basically an AST in your normal language, right? But I will have later. So here's what I'm trying to evaluate, right? This. Usually you just do an AST like that, right? But I will have also the type information here from the type inference associated. So like with every expression, I have not just the AST, but also like there is going to be the type inferred here later. There's going to be a span of the code and like all of the other things attached here. So what do I call it? I mean, I just call it expression here. I don't even call it intermediate representation anymore, but I was calling it the intermediate representation. Like the AST is the actual parse syntax. The parse syntax going to be converted into the core syntax, which like is no longer extensible, at least for now, I think. So the AST that I call the AST can have the nodes defined by the user. That would be implemented through macros. But this just represents the core syntax. Plus, it runs on the like on the enriched AST with the type information, which I mean at this point you can call it intermediate representation, right? It's just a high-level intermediate representation. Okay, let's have or math. Let's have variables. Let's have variables. Variables. So we need to have first of all I need to extend the syntax, right? Let's see. We want to have syntax for I was actually, so like if we want to have something like let x be y, right? Then I actually was doing this in two parts. First of all, we have the assign syntax. Wrap is ever is let's see. So we have assignee is equal to value. Or yeah, sure. Just do that. Okay, and then we have syntax for let. So this one is specifically making an assignee expression that is just a binding. So we will have assignee expressions. I think I will just go there from the beginning. This over here, by the way, should be a place expression. So do I just do this from the beginning? I think maybe. I don't know, maybe not yet. We can start with this, just assignees. So we have a let pattern here. So what should be the priorities though? So that it parses correctly. Should be lower. They both should be lower priority than the all of the operators like that. It should probably be around here. I mean, the if should probably be not one, but like 2. I can just use the existing ones. This one should be higher. Assigning, yeah, let should be higher than that. So 3 and 2, something like that. I don't want any associativity on this. So it's fine, yeah. We can try to see if it been formatted properly. Being highlighted properly. I'll restart this. So I can say let x. Let's see. I can say let x. Okay. It should print this space here. Let's print space here and print space here and print space over here. Because otherwise the formatter removes this white space. Should not happen. Okay, there we go. So I can say let x be 3, right? And then we can say 2 plus x. Like this should work. Okay, so we now we need to assign have the assignment expression. Would x equal 2 be parsed now though? Yes, it will. So like we can say that, we can say x equals 2. Yes. This should be like this is already parsable. Yeah. We had that working before too. That's exactly how it was done before. This means mutation. Should be only allowed if this is mutable, but like whatever. For now. So I need to have a new type of an expression, which is an assignee expression, and then from the core syntax, I will also have the assign, right? Make bnob should be right here. Assign. Oop. Assign string and handler is assign function compile state children into let. So we have assignee and value tuple unwrap names 2 which is assignee and value like that. Do I prefer the pipe here? I don't know. Maybe feels like a method then. Okay, so we have compile. This is not what I want. Okay. I need to have I feel like what I want here is to use the first class module thing here. Yeah, I feel like that's what I want. Let's try to using the first class modules in OCaml, because like once again, this is the compile function is return an expression, but what I want is I want to compile an assignee expression, which is a new one. Let's have a to do here for now. So yeah, we have this to do. Yeah. So instead of having compile and state like this, what I'm going to have is just have a compiler. So we have access to the compiler, right? And what is the compiler? What is the compiler? Compiler is Compiler is compiler signature or something. Let's see. OCaml first class modules. First class modules introduced this pattern syntax and package interface. Something. We have module type device. Oh yeah, you just say module device here. Okay. So just say module compiler s like that inside parentheses, and then it works. Okay, good. So what is compiler s? Let's have a new file. Compiler. Oh, so we have a module type s. Sig. So we want to compile expression, which is what AST state expression. Well, like that. So then we have type state, right? That's my signature. Okay. Yeah. Yeah. The expression has type string into compiler. Okay. Oh, because compiler. There we go. So now we say compiler dot. How do I use this though? How do I use this? How do I use this argument device? Devices. Can I maybe just say like compiler as compile expression compiler f? I cannot. Unbound module compiler s. Cast language server crashed. Nice. I mean, that makes sense. Unbound module. There's a module type, but module types are not modules. Yes. So how do I call this? If I have a value of with this signature, maybe just I mean I would expect it to just be a field, no? Like a method, compiler.compile expression. No? Like the type of this. There is no type definition. Expression has type compiler s, which is not a record. Okay. Where is the example? Device draw. Let. Oh, we say let module device. Wait, hold on. What? No, let module device is fine. Module type device. Module device. Oh, wait. This over here is capital. Should this be called capital compiler? Module device. No, this is the type. No. Hold on. Devices. Hash table. Basic example. This is bad example. It doesn't tell me how to use it. Module SVG. Hash table add devices and module SVG of type device. Okay. Sure. We can then select one implementation based on the command line arguments. For example, parse command line, module device of type device is this. Alternatively, the selection can be performed within a function, let module device. Okay. But how do I use this? So we have the sort with a module set being an argument. Oh, I see. So do I say over here module compiler? Is that what? Is it because it's a named one? This is syntax error. This would work though, right? Still syntax error. Line 10. Where's the syntax error? I'm doing, oh, well, I need to say module compiler. Compiler s, only then. No? You didn't like the command line args parser, so you just used sysargv. That's what I did too. But I didn't even know that there was an existing command line args parser. I didn't look at it. But maybe it's actually better, I don't know. Syntax error, module expression expected. Oh, it should be like compiler, like that. There you go. There you go. Like, this is impossible to represent, right? With a named module argument. Probably impossible. Yeah. So over here, then we say, like, that's compiler dot compile expression. There you go. That works. Okay, good. Compiler, compile expression. But if this is a module, a first class, then I feel like the module can have the state inside already. And then I just say compile AST. And then the state is already inside of the implementation of this signature. And then we just say compile expression like that. Module compiler. Can I say module compiler like that and it's going to be automatically figure it out? Compiler. Compile expression. I guess this works because the type is inferred from over here, right? But this one, the signature for this package module could not be inferred because this thing is stupid. Okay, sure. Compiler S. Okay. Maybe we do the same for the interpreter then? So this function is specifically compile expression, right? This one is specifically compile expression. So the compiler here, I can say just can I just say module? Oh, can I just say struct? Like that here? No, I cannot. Can I do it without the let module s? Handler. Compiler. Oh, it should be like module. I think maybe module struct end. That works. Now there's the signature doesn't match, right? So we just say compile expression. It's compile expression. It's compile expression state. So we don't have state anymore. There you go. That works. Although having this is in line, that probably like maybe the argument of this. Wait, but this is like defined inside of itself. I can probably not refer to the module while I'm defining it, right? Probably cannot do that. Probably cannot do that. So like, for example, the initialization of this, should it be that? Or should this return the module? Maybe this thing should return a module already. No, but then I would need to, like, inside of the definition of the module to do that. Yeah, it's weird. It's weird. There is another alternative, which is the object. So Camel also has objects, which is similar to first-class modules, I guess. Compiler could be an object instead, for which we could be having methods. So compiler would have a method. But now we have this, like, we have it kind of recursive, and that's why we need it, right? Because the core syntax depends on the compiler, and the compiler depends on the core syntax. And for that, to break the loop, we make this, I guess. Which is probably fine. Yay, OOP. First-class modules is similar to OOP, I guess. Not exactly, though. Compiler, compile. Compile expression. Okay, like from the outside, it's going to be a normal function that takes the state of the compiler, though, I think. And then inside we can do that. Okay. Now we have the to-do inside of the compile expression. Now, because now this is abstract, so I cannot go to the definition. Beautiful. But it's over here. Wait. Where is the to-do actually happening? Can we have, Nigel, the stack traces that actually work? That show me the line where the expression was thrown? I mean, it was raised over here, yes. It was raised over here. Am I catching them anywhere? No, I want them when they are printed to print the stack trace. Well, I mean, I'm kind of catching them, but not exactly catching, right? I have the exception. This. So I'm registering a printer for this, and I'm printing the backtrace, but it's printing the backtrace, but not in the entire backtrace is the problem. Not the entire backtrace is being printed. Like inside of this compile expression, I am inside of like actually somewhere else. Yeah, see, like I was compiling then, I wasn't compiling then, and then inside of that I was compiling something else, which was specifically the assign. This is the to-do that is actually failing. Like if I say to-do 2, I will see a to-do 2. That's the one that's failing, but I don't see this line in the thing. Can I, maybe it's because I'm doing a KD printf or something. Can I record the stack trace here? Print exception, record backtrace. Like get backtrace is what? That's a string. Why is it a string? Get backtrace return a string containing the same exception backtrace that print backtrace would print. That's a different thing. What's record backtrace? Record backtrace turns the recording of exception backtraces. True or off. Okay. Well, I mean, no, this is no. This is fine. This is fine. KD printf is actually fine. Because this is going to be called. No, this is fine. It's because of the formatting magic that they have in OCaml. That's fine. This is going to be, like, I'm actually erasing the exception when I'm calling this function over here, right? So this is my argument, and this returns in me raising the exception. Let's actually even try over here instead. What if I say raise failure? What if I say raise failure to do 2, right? What's going to happen? Then I see this actually. But why do I not see it in the other place? Because it happens in the other function. I feel like some stack traces are missing. I mean, they are missing. Like, look even at this. Look at this. So the stack trace says that the exception is thrown over here, and then the next stack trace is over here. But between me calling this and me getting here, we actually have some other stuff, right? So what is the compile expression, right? I'm calling, I'm still calling this function, but it's not present in the stack trace. Why does OCaml skip some functions when printing stack trace? Can I fix it? Because of tail call optimization and lack of debug information. Compiled without debug info. You're building without the G. How to fix it? Compile with debug info. Flag standard G. Where should this be? Where should this be? In every single Dune file? That doesn't fix it. Maybe in the main binary? Maybe in the Dune workspace, actually. Add dash G here. So we have a sign, and then we have a then. No, it still is not there. It's skipping functions because of tail call optimization, right? Top level calls inline code. Sometimes OCaml inlines things, which means no traced. Don't tail recursively optimize for debugging only. If you're desperate, make your function non-tail recursive on purpose while debugging. OCaml format and inline never. Using Flamda. Use Rust. I don't know. It doesn't fix it. I'll keep the G in the Dune workspace so that everything is built with G, but like it doesn't do anything. Okay, anyway, let's just implement the assignment. So now the compiler, now that I have the compiler, no type definition. I cannot go to the type definition. This thing is stupid. Compiler S. The language server doesn't work. So we can, I want to be able to compile assignee. This is AST into assignee expression. So expression, we have assignee expression, assignee expression shape, and assignee expression shape. So I just call it A, I guess. Assign. So we can assign to a binding. It's very similar to a pattern. Assign to a bind. No, assign to. Yeah, assign to a binding. Assign to placeholder. Hello farmer. Assign to a placeholder, which doesn't actually do anything. Assign to a binding, or assign to assign let of pattern. Okay, that's what we do. So now we say that cast compiler, we need to say compile assignee. It's compile assignee. So we have this recursive stuff. And compile assignee. It's very similar. We cannot make it very generic here, can we? So this assignee expression has been returned here. Now, if we have an identifier and we assign to a binding, if we have a string, a number, I cannot assign to a string or a number. And assign to string. And assign to number. Just to write in OCaml. I have a feeling that I'm kind of close to dropping it. But like, I don't know. Maybe not. Like I'm suffering here, but at the same time, it does compile pretty quickly. Do I do a new rewrite in Rust? Like, I feel like I don't know, I will get eventually to the same place where the Rust compiles in 10 minutes. How do I have a good language and that has like everything in it? The good compile times and the good type system and everything. Gonna make cast fast. Yes, we just rewrite cast in cast. That's right. But we need to get there first. I mean, this time I have a language server. Maybe like that would make me be able to go to cast. Like just the formatting and highlighting is already like giving me a lot in terms of enjoying to write that stuff, maybe. But like, I feel like it would be like the previous compiler was, an interpreter was definitely slow, right? So I would need to go into native compilation, make that usable anyway. Okay, we have complex. We have that. So we have handlers. Okay. So the way I was doing that, actually, the handler was doing this. We have a compiler, and I want to compile into a specific type of expression, right? So we don't have just an expression. We have a compiled type. And then we return compiled here. You know? Where compiled type is either assignee or expression or pattern, you know, one of those. And then compiled, I guess this should be called a kind instead. So compiled is assignee of assignee expression or expression of expression or pattern of pattern. And then there's going to be also the place expression. But wait, hold on. Can I do that with the GADTs though? Can I do this? Underscore assignee is assignee expression compiled kind, right? That's what I do. Expression is expression and pattern is pattern. And then I don't need the compiled. So we have so I have a generic compiled to kind A like this. So can I have a handler to be a generic one like this, which returns A? The type A is unbound. Wait, do we not have this? Type A is unbound in this type declaration. So can I not have a for all in the type declaration? Or maybe I have a function that accepts type A and then returns that. No? Like, you know, why can I not do this here? I can only have polymorphism. Like, can I not have polymorphic values? You know, camel polymorphic values. Polymorphic values allow function and data structure to work with different types without needing to specify those types explicitly. Polymorphism has its limitations. Like, I want to store a polymorphic function, right? Okay, can I store polymorphic function in a type? Yes, you can store polymorphics in a type, but you have to find the type system, like a gladiator. Because it wants monomorphized functions unless you explicitly box the polymorphism. So this is a syntax error, right? Why? Because this is a rank 2 type, and we are monomorphic by default. So we need to do f. Wait, what? You need to locally abstract types or first-class polymorphic functions like a pro. But only certain places like record, fields, function arguments, etc. and only a camel 4 plus. I cannot have it in a so not in a field, right? I cannot have a type alias like that, right? That's what you're saying. So if I have a handler which says handle is that, then I can't do that. So that's correct. But a type alias which is polymorphic is impossible. Okay, got it. 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 Can I just have instead of string times handler, I want to have a handler. Name string. Yeah, let's just do that. This, that, that. Is going to be name is equal to that, and then handle is that. And then this should be now a struct. And then this, okay. Hold on. Name is equal to apply semicolon, opening bracket, and these are closing. And then these functions is handle. There you go. Okay. Right, and now this takes in the compiled kind. This is nice, actually, I think. Kind, right? So kind in this case. Huh? The field has type. Pattern compile type. Oh, because I'm returning a pattern, because this it thinks that it's a pattern, right? Yeah, so this needs to, I need to actually like match on the kind here. And to actually, now I need to match on the kind. Match on the kind. And if it is expression, then I return that. Kobe thinks everything is competitive. Now there's even ranked types. Higher ranked types. Yeah, we have like I'm trying to use the generalized ADTs here for the first time. I understand the concept, but I never actually used it in practice. I feel like this is really nice because in Rust, with the way I was doing this, I had a runtime check, and this allows me to eliminate the runtime check completely. So basically, I know that if the argument to the function is this value, then the result of the function should be this, you know? Well, you cannot have that in Rust. In Rust, to do that, this would be instead as like all of these needs to be like separate types, and then you use like traits to specify the output. Kind of, you'd have to have separate functions or do like traits, yes, on the separate types of each variance. So basically, I know that if I'm compiling an assignee expression, that I will get an assignee expression as a result. This is like the very simple form of it too. So if I say anything else, then fail. Apply must be expression. Okay. The field has type. expression. Okay, you know what? I feel like this is not like OCaml polymorphism. Can I like make the things higher polymorphic? Like it infers it as being non-polymorphic here. I can have over here type A like this, and then that will be kind of a compiled kind, right? Still has value, compiler pattern. Is less general. What? Don't lie to me. I literally made it have the type argument. Where is this coming from? Oh. That's not the issue. That's the fake warning, right? That's the fake error. It's just it cannot figure out what is this type now. This is compiler S. Okay. E apply. There's no constructor with pattern shape. It's thinking that this must be a pattern. Because it cannot figure it out. Even though the type information is already there. This language is stupid. Guys. Now what? No, this error is still here. Okay, what's the error? The field has type module compiler S into expression, which is less general. Now it thinks that I'm always returning an expression. Let's do this. Let's do this. That's why I'm scared whenever Kui opens my code. How is those amazing languages stupid? I think it like figures out that the type of this is expression. Like even though I have specified this as like a type A, it still thinks that this function is not polymorphic because this is stupid. Let me do this. You know what? Let me do this. Let handle this. Well, I mean that would be the same thing though. No. So this should return a. Wait, now it works. It was missing this annotation for some reason. Okay, because if I don't specify this as a generic type, then it's trying to figure out that this should be a concrete type. Yes. Okay, yeah, that makes sense maybe. Maybe. But like the type inferences of OCaml, I don't like it. I need to specify too many types manually. Do I even need to specify this now? Maybe I can get around with just that. I can. Okay, good. Because it's over here. Okay, there you go. We have GADTs. Compiled kind. Sure. Sure. There is one thing that OCaml does better than Rust. I found it. Okay, so we always do this, right? We always do that now. And then I match kind with I match kind with expression and then this. And if it's anything else, then I say fail, then I must be expression, right? Because this cannot be a pattern, a semicolon. A semicolon B, can this be a pattern? Probably not, right? Apply could be like used for variant types. Okay, scope. Scope can be anything though. Assign must be an expression probably. Kind. Okay, so over here we match kind with, like, so we can have patterns inside the parentheses. We can have expressions inside parentheses. We can have assignees inside parentheses. So that's fine. We just say if I'm doing an expression, then I'm doing that. If I'm doing an assignee, then I'm going to, it's going to be like literally very similar, right? But if I'm doing an assignee, then I need to compile assignee over there, and I just return it as is. For the assignees, we don't have like scopes. That's literally what I return. That if I have patterns, compiler compile pattern, like that. So compile pattern AST into pattern. We don't have that yet, but we will. Okay, and then for the binary operators, this should return a handler. We'll return name, and handle is that. And now this function is like this. I'm just going to match kind with expression. Then we do that. And if it's anything else, then we fail. Binary operator must be expression. Okay. So yeah, this just means that we cannot have a plus operator in a pattern position or in an assignee position, but the parser allows that. Okay. All right. So we have assignee and value. Now, I'm going to say here that assignee is compiler compile assignee, and then value is compiler compile expression. For now, it will be a place later. Value, and now it's all over here, and then I return expression assign, assignee, expression assign, assignee, and value. Shape is that. Now that we need to have a new expression, which is assign, expression assign. Expression assign is assignee, assignee expression, and value expression. Okay. I'll keep every variant its own type, just in case I want to do it later. Unbound value compiler, module compiler. The signature for this package cannot be inferred. What do you mean? It's literally over here. Okay, I cannot click this over here. When I'm evaluating an expression assign, assignee, value, then what I need to do is I need to evaluate and to first evaluate the value, right? And then, so this actually will return value unit, right? But we need to assign. We need to assign similarly to pattern matching over there. So I'm going to mutate this state of the interpreter here. Or something. Wait, do I want to have mutation here? Probably yes. Or we return a new state of the interpreter. But I think there is no reason for me to save the state of the interpreter. The state of the scope, though, probably. Yes. Let's have this to be mutable, though. So I just say that state scope is so we have bindings where I don't have a nesting scope. We just have a single global scope for now, but it's fine. So we do string. No, we just do. We don't do pattern match, but we say. Hmm. It's not exactly pattern match, right? Let's have assign state and value. So I'll have the function assign, which takes state, assign expression, and value, and returns unit. So there's going to be function state, assign value. I'm going to match assign with assign shape. If it's a placeholder, then we don't do anything. If it's a binding, yeah, I can do that for now. Name or a let pattern. So if I have a let pattern, then I will do pattern matching. Pattern matching needs to be above for that to work. So in this case, we do pattern match, value with pattern. And this is new bindings. And then I will just say state scope is bindings is add bindings. Bindings is add bindings, state scope bindings, and the new bindings. Just add them. That's fine. Over here, I'm going to do the same for now. Even although this is mutating. I'll try to get into like places as soon as possible, though. Be nice or else. Hello there. I'll try, but it's not always possible because I'm hungry and I'm riding on camel. Riding on camel makes me mad, so you have been warned. I'm just going to add bindings here to the state. So bindings. State scope. We assign that. And I'm going to add just the string map singleton of a name value. So like it's very similar to pattern matching, but that's just for now. Assign state assignee value. There we go. Yeah. Later, this will also be recursive because we'll have like tuple assignments and stuff, but for now we keep it simple. What is that? To do remove. The expression has type handler list, but the expression was written on type string a list. Yeah. How about we do this and then string map of list, but before that we do list map handler into handler name and handler handle. I guess that's what I want. I get fun here. Oh my god. Hold on. I cannot return the handle here. Can I not? Because this would mean that I'm returning a polymorphic function, but the return value should be not polymorphic, right? Wait, no, but string map is a handler. Yeah, no. Yeah. Wait, okay, I cannot have type alias to a polymorphic type, right? Can I have a type alias to a polymorphic type, like type who is a into unit? I don't know. No, you can't. At least not directly. The command explicitly forbids type aliases. So that's what they mean by boxing, right? It's just unfortunate that I cannot have a type alias like that. They cannot encode binding structure like that. Yeah. Well, I mean, but what I can do is I can probably, like, what I want is I want to extract this into this over here, into a handle, right? So can I have a generic type though? A handle is that, right? That's what I can do. So, and this one over here is polymorphic then. That's why I have the alias, kind of. Yes. So this over here is not a handler string map. This should be a string map to a handle A, right? But this doesn't work. Can I not have the argument to the string map to be a polymorphic type? I guess I cannot. Okay. I guess in this case I just store the handler directly there. So I just have a handler and I return handler name and handler. Like that. That will work. Kind of impressive that it reads like regular English. Do you like this, where your generic arguments are before rather than after? So in Rust, you write, you know, like map key value. But in OCaml, you basically write key value map. It's weird because like map is like a function, kind of. It's a type function, right? It's a kind, but the argument is on the left side instead of on the right side, unlike normally when you call functions. I'm wondering what's the reason for this is. Is there other languages that do that? Because I think I have only seen that in OCaml. Like U32vec, yes. Kind of cool. Yeah, I don't know what I think about it, but yeah, it's weird. But it's sometimes it's nice. I don't know. Like I think like generally when we talk about syntax, the most important question usually is like should the thing be before or after? And like that's always that's why you won't have like the pipe operator, right? What's the syntax for applying a function? Is it function argument or is it an argument function, right? And we basically want to allow both because it depends on the situation. Maybe like for the types, it also depends on the situation, kind of. You know, like do you do await future or do you do future dot await, right? So like languages like most languages they decide on that, but we can have both syntaxes without problem. Like it really depends, right? On the situation sometimes maybe. Like similarly to that, I really want to have an option to assign to values. So like right now we say assignee is equal to value, right? But I want to calculate the value first and then store it inside of the assignee, you know? I really want to have that syntax sometimes. So like the only alternative to that, like there is not even an alternative to that because like especially in Rust, the value, this is a place expression. So you cannot even store it in a temporary variable, really, because you cannot do that. Yeah, anyway. Your custom VS Code plugin has a mode where it hides the brackets and they are unary. Well, I mean, yeah, but like, I don't think the question is more about like the type of parentheses, if it's like the angular brackets or there's no brackets. It's more about which comes first and which comes second. But yeah. Maybe they expected type constructors to have a lot more nesting than values. I don't know. I don't know, they just have different syntax for some reason in different places. Okay, so this handler now needs a type. Yeah. So I think actually, so like I actually want this to also be there. Can I have a recursive? So we want a recursive polymorphic thing. Wait, holy shit. I need this to be... Wait, can I have this in a module? Hold on a second. So I don't even need the compile... I just need a single compile thing, right? Can I just have a compile? You know? So like this is my signature of the compiler, right? Instead of having three separate functions. We just literally have this compiler kind. Right? Let's just have a type compiled kind is compiler compiled kind. I cannot just use thing. I must repeat myself here, right? So this over here, I just have the signature. And if I have a signature with a single function, then I just have a function instead of a module object. But I cannot have that, or can I? Can I have a polymorphic function as an argument in OCaml? I don't know. Do we have a function compile instead of these three? Which be compile, which be like for all a compiled kind into AST into a, right? That's what we want. That makes sense. So instead of saying compiler compile, I just say, so instead of saying compile expression, I just say compile expression. You know? Yeah. Compile expression. Compile assignee becomes compile assignee. And compile pattern becomes compile pattern. Okay. And then this compile should also be a generic one, right? So we say a compiled kind right? Like that. So yes, over here, yeah, so like instead of having these two separate functions like I was having before, right? Yeah, like now I don't need these separate functions copy pasted. We have a single one. This one is a function state kind AST. This returns a. I feel like I need this type A to be specified here, where kind is a compiled kind, right? Probably need to do that. So this handle with this, the children. This over here. Can I turn off the like the red squiggly lines? There's too much of them. So in this case, I will actually, in case of a simple one, yeah, in case of a simple one, I will match on the kind. And if this is an expression, then I will do that. And if it is anything else, and if it is an assignee, then we have something else. And if we have a pattern, we have something else. Fail to do pattern. This one it would be kind of similar, but not exactly, right? That's the code that I had just deleted, by the way. So string and number, fail, string cannot be assignee, number can't be assignee. You turn them into straight lines. Less annoyed. I feel like there should be a button to toggle them on or off. Whether I'm ready to check or not yet. The constructor AST symbol belongs to the variant type AST shape, but the constructor is pattern shape. AST is AST. E-binding. I expected assignee. Yes, so like in this case, in the identifier, it's an assignee binding. That makes sense. Now we have signatures don't match. Okay. Now we have a signatures don't match thing. Where? Over here. Compile is compile state. Yes, I probably understand why. Because so like I need this to be a function a compiled kind into AST into A, right? That's what I need. So I need instead have a function kind into compile state kind, right? A. No. I think I need I think it doesn't work like that. We need to have a function type A kind, a compiled kind AST, which returns compile state kind. Okay, this returns A. Compile is function. Yeah, this should be an arrow. Okay, this function has type state into expression, which does general and A. State expression. Wait, what? So this should be the compiler S, right? You know what? We can just do an end. You know? Yes, we can do an end. Yes. Compile with the compiler. You know? Because like if I have the compile function, then I can define what the compiler is by saying compiler is this module. Oh wait, hold on. Can I not do that? Can I not say that the compiler is a module? I can have it as an argument, but I cannot assign it to a value. Oh my god, this language is weird. Like I can have something as a value, but I cannot assign it to a binding. I mean, there's a dedicated let module thing, which would allow to handle that, I guess. Okay, this is the actual error. The expression has type ASTT into expression, but expression was created as type that. Which expression? This? AST. Expression type expression. It does not have the type expression. Are you stupid? It's a generic one. The expression has type comma A, but the expression was expression of type A. Type constructor A would escape its scope. Oh, because it's this is type A and this is also type A. Wait, okay. Oh wait, no. We just need to do this A. The value kind has type A compiled kind, but expression was expression of type A. Where? Kind. Kind has type A compiled kind. Over here. But it was expected of A. Of this A. Is this A and this A different A's? They are. Let's call this B. The value kind has type B, but an expression was expected of type A. The type constructor B would escape its scope. What's the actual issue here? So compile is a function that takes state, kind, and AST and returns based on the kind. The type based on the kind. And shouldn't this work? Did this work? I don't get it. Is this signature not correct? This signature looks correct. Oh my god. Okay, how about this? So instead of having, like, since there is just one thing, a module as a first class object is basically same as saying that type compiler is a struct with compile being a field of this type, right? Like it's literally the same thing. It's supposed to be literally the same thing, right? So instead of having in the core syntax. Hold on, let me do this first. Let compile of type. Oh, but I cannot. Yeah, no, I can. Of type compiler is compile is this function. Can I do that? And then this compile be compiler compile or something. Let me just in fact just do fail to do here. So it says that the expression was type A, but the expression was type B. Yes, see, this is also not working. Why not? What's the problem here? Any occamlers? Expression has type A, but expression was expected of type B. Compile is a function, state into A. But wait, no, compile is polymorphic. Help with a recursive polymorphic. I think there was something about recursive polymorphic functions. They are a forbidden fruit. If you try to write something like this, retrorec A is this, then this is a compile error. Okay, I think that's exactly, yeah, the type cannot be generalized. What? Because you cannot have polymorphic recursion function with an explicit A annotation directly. Common type doesn't support generalization of type variables in recursive definitions. It keeps recursion monomorphic, so it can assign a new A for each cell, for each call of F. This means recursive polymorphic functions must be wrapped, like the cursed gifts they are. Use an expansion plus helper functions. Let F be. Let's rec. Oaks X is Oaks X in that. Oh, I see. Maybe. Or if you want to make it explicitly polymorphic. Now if it's polymorphic because it isn't the recursive one, aux is. Yes, so like we have a helper that is recursive, but this one is not recursive. Interesting. Oh, workaround 2. Use recursive record with polymorphic field. Here, the recursive binding is to the record, not the function. The field is polymorphic and a camel allows it. Use GADT existential wrapper. Type poly is poly A. Oh, that's the same thing as having a field, basically, right? Yeah, sure. Yeah, that's just the same thing as having a field. Use modules to encapsulate recursion. Module type polyfunction is this. Isn't that what I was doing already? Module rec m. Oh wait, you can refer to the module itself here actually, huh? Wait, you can refer to the module itself here. Wait, can I? Hold on a second. So can I just say that over here I want to have a module compiler of type compiler s is equal to this struct, right? Which has the thing inside. It doesn't match. Modules do not match. Signature value compile state. Oh, because we have a state here now. Yeah. Never mind. I mean, I would return that from the init function, I guess. Kind of. Okay, like right now everything is compiling, right? No, not everything. This over here, instead of compile expression, should be compile expression. No. Compiler expression. Okay. We have a to-do. Over here, right? Let's see. I just need to figure out how to call this function, and then it's going to be easy, right? It says here that this is unbound value compiler. Compile is compile. Compile. Wait, did I remove this already? Compile. Type B. Kind B compiled kind. AST. This returns A. Returns B. Compile. State B. Kind AST. Kind has type B compiled, but an expression was expected of type A. Yep. Okay, so the problem is the recursive polymorphic shit doesn't work in this language, right? Yeah. So I need this to be not recursive. But if I make it not recursive, then like compile is not even known here, right? Compile isn't even unbound. Oh my god. This was going so good with the GADTs, and then this happens. Make compiler. Can I have that? Can I have a function? Make compiler. This should return module compiler s. To do. Yes, this works, right? I can try to return a module. Although this one says, yeah, I need to have the same kind here. Oh, wait, maybe that's the problem? Why do you say unbound? Oh, yeah, this needs to be like recursive. Yeah, so like this works. Maybe that's the problem because I forgot an argument here, actually. I'm wondering if that's the case. Expression? No, this is still saying wrong. So how do I make the compiler, which returns this? Unbound value state, actually. Make compiler state. State has type unit. No, state should be having type state. And now over here, I will say state. Wait, no way. No, we still have this issue. Still the same error. The value kind has type B compiled kind, but expression was based on type A compiled kind. I'm gonna reach QuitoCamel, hold on. Let's have a simpler example. Let's have a simpler example here. Let's have a simpler example. Something like this. Let rec foo type wait, hold on. Hold on a second. I assign it to a function. What if I say compile like that? And then I say equal. Does this work? For some reason, maybe this is different. No, it's not. That's the same thing. Okay. Okay, so let rec foo type A is fail with to do, right? And then I want to have end, and then we have type contains polymorphic is the thing that contains function a, which is for all a into unit into a. I don't know, for example, right? For example. And then we have make poly contains poly is the thing where f is equal to foo. This thing is less general. This thing has type unit, right? Let's just try to ask ChatGPT. Fix my OCaml. It can do it, right? You're trying to use a polymorphic function foo as a field in a record with a rank 2 polymorphic type. OCaml can do this, but you are tripping over the order and the structure. You're defining a recursive function that returns a, but it's unclear how a is determined. You're trying to stick foo directly into a record field that has a rank 2 polymorphic. Yes. OCaml does not infer polymorphic type in record fields unless you explicitly annotate. You need to force OCaml to treat the function as polymorphic by eta expanding and using object magic. If you're trying to delay actually writing the implementation. Here's how you might do it properly. No, you're lying to me. That's going to be not correct code. Wait, this is correct code. Wait, what? Hold on. What's the difference? Let me see. Looks like that compiles. So what's the difference? The foo here, I annotated with that first. And type A is similar to doing that, right? Or is that different? Is type A different? No, this is the same thing, right? This is polymorphic. Okay. What is the difference? Hold on. Between this and that. This says the field has... So like, just this notation and this notation is different? Still? Even though I have made an explicit type argument here, it is still not polymorphic. So I need to still annotate it. Wait, but this one has 2 arguments. Wait. This one has 2 arguments. That's the problem. I don't want to have 2 arguments, right? Can I wait? Hold on. If I comment this, but I comment that, but I remove this, so this is just a function from unit into a, right? Oh wait, I just had the wrong types. I'm stupid. Contains poly is supposed to be unit into a. That is still like the way I wrote it, right? So like this, that works. And if I say this. This also works. Okay, good. Now we use the GADT. So type underscore GADT is foo, which is I don't know, int GADT, for example, right? We can do that. So this function, I wanted to have a GADT. So we have a GADT into unit, or like, I don't know, GADT into a, whatever. So foo type a, which takes then the x, which is a GADT, is this. This works. Okay. Okay, what's the difference then? What is then the difference? So we have compiled kind, right? I want to have the function over here that is compiled, right? Is it because I'm calling it? It's probably because I'm calling it. Like, what's the difference here? Because I'm making a new one, right? So how can I have over here another function? You know? X into foo x. That works. Wait, what? Make compiler is like I need to use it using an existing recursive thing, right? Which is that thing, compile. Oh wait, maybe it's because it was inside of a rec? Hold on. If I say over here end, hold on. What if I say over here end? Then it doesn't work. There you go. There you go. This makes no sense now, right? Because this should be the same. So they said then, if you insist on mutual recursion, this kind of garbage works, but it's ugly. Now foo calls make polyf, which is foo, so it's a self loop. Hope you like step overflows. You're saying that this works, but this is just calling itself recursively like that, which is not correct. Well, I mean, hold on. Wait. Why is this not correct? Why is this correct? Isn't this the same thing? Hold on. Isn't that the same thing? Okay, hold on. I need this to be specifically... If I say that that f is foo here, yeah, this still doesn't work, right? Now this code. Fix. Rank 2 and GADTs. You don't need to rank 2 polymorphism. No, I need. Keep the polymorphism, but make it honest. You really need to keep this. You must cover every constructor of the GADT. Yes. Make poly. This works. But I cannot have an end here, right? Wait, I can have an end. Hold on a second. What? What? So the difference... Okay, hold on. A difference again. Ooh. Type A. X A G A D T. And this doesn't work. What is the difference between this and that one? What's the difference? This is literally the same. So this is now just a different syntax, right? And this one says the field has type A, which is less general. So if I have the annotation here, like that, then it works. Wait, what? What if I have an annotation like that? That's the same thing, right? Yeah, that's the same thing. Okay. That's so weird. So it's because I don't have the annotation here. A state a compiled kind AST into A is fun. And now I need to have an arrow instead. So this is the same thing, and I want to make struct here. It works. Wait, what? That makes no sense. That makes absolutely no sense. So the only difference that we had is I added the type annotation here, even although the types are completely annotated on this function already. Right? Whoa, Cleaver, hello. Random question, what's the mic you are using? It's a Samsung C01U Pro. I don't know. It is like 20 years old or something. It's also like half broken over here. It was falling down. It's like breaking apart slowly, but it's still alive. I think I saw Sodin's mic and it looked similar. Maybe the same. Maybe it's the same as Sodin's mic. Not sure if it's exactly the same model, but yeah. Okay, there is no core syntax let. Okay, guys, we are making progress. I have no idea. Like, did you understand this error, Nigel? Do you understand this? I have type annotations here, but this is not enough. I need to add extra type annotations over here. Makes no sense. And then it just works. All right. Whatever. Whatever. There is no core syntax let. So now we need to have core syntax let. Let. So let is this. Let just has unwrap single named pattern. We just have a pattern inside. We just have a pattern inside. This thing must be an assignee expression, right? So I need to have an assignee expression let where we have the pattern, where I will say that the pattern is compiler compile a pattern of a pattern, right? I think that's all that I need to do here. A let contains just a pattern without like even nested types here. Okay, fine. So this is a let. There you go. Now we have a to-do pattern. To-do pattern. Okay, the stack traces are bad. To-do pattern over here. So I'm trying to compile a pattern of a simple token, right? And this is where we need to match. So I guess the string cannot be a pattern, right? Or maybe not yet. An integer cannot be a pattern, at least not yet. An identifier can be a pattern binding, like that. There we go. There is no core syntax statement because I have the final statement. What did I do? What's my example that I'm trying to compile? Yeah, we have the final thing. I'll remove this. Okay, it works. It actually works. Look at that. Restart cast. I think I need to reload the window for the cast analyzer to work. Yeah, there we go. This works. This returned 4. So we have assigned to 3, then I reassigned to 2, and then I did 2 plus x. And it works. Okay. Okay. Let assign works. Let's have some other simple things. Let's have underscore. Is this should not work. I mean, this will work right now because this is an identifier. I'm not checking that identifiers exist right now. I'm just making a new variable like that. But I guess 2 plus underscore over here. This will say that not found, but I should do something different. Like I won't have the placeholders to be compiled. So for that, we actually the underscore is a keyword. Underscore is actually a keyword somewhere and in the end here. Syntax core placeholder is just an underscore like that. So this will now say that there is no core syntax placeholder. So in the core syntax, I will also have a placeholder. 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 Placeholder tuple assert empty children. And then we see if it is an assignee, then I return. If it is an assignee, then I return assign placeholder. If we have a pattern, then we return pattern placeholder. If it's a value, then this is going to be inference. But we don't have that yet, right? Yeah. So if it's expression, then I say fail to do placeholder expression. There we go. So now this is what it's going to say, play to do underscore expression, but we can use the underscore in other places, right? I can say underscore here equal to, and this will now actually be a keyword. And yeah, like that. I guess I can say that assign, you know what? We can check that at least the assignee, you know, let's do it in a simple way in the interpreter, so that if I try to assign something without let beforehand, then it should just like panic or something. So if I'm assigning to a binding, I need to at least see that the name already exists, right? So if string map find is if find in state scope bindings the name is none, then I do something like fail need trying to assign to undefined variable. This should although fail compilation, not its runtime, of course. But for now we do that. So this doesn't actually fail, right? This doesn't actually fail, but if I say over here y instead of underscore, then it will say that trying to assign to undefined variable y. If I do x, then x will work because x already exists. There we go. Nice. Nice. This is progress. This is progress. What would be next? I think that maybe I want to have the place expressions immediately, and then we will work on the type inference. And then as soon as I have the type inference for this simple language, I want the LSP to have the hover, so that I can hover on the X here and see that the type is int. Right? And then I'll hover on the print and see that the type of this is a function from string into unit. I want that to work, and then we expand from there. So we are going to do that next time, I guess. Good enough for today. I'm going to go chill. Best commit message of all time, underscore. Well, that's what I was implementing, right? The underscore. The commit message makes sense here, not just a random symbol. Right? Why rename from built-in to core? Because I think I don't know. I mean it's the same thing. I mean, yeah, maybe. I don't know. Do you like built-ins more? The thing is, I was calling it not just built-ins, I was calling it built-in macro. But it is not a macro anymore, right? So I was previously calling it std syntax here, right? This was called built-in macro. But a macro is a thing that I think... so a macro is a thing that spits out new code, right? But this does not spit the code anymore. We can just keep it a built-in, but it's not a macro, at least, right? Like macros are how we implement custom syntax, which is not in the core. Yeah. Because macros generate code and the core syntax generates the intermediate representation. I guess that's the difference. Macro should be optional, but you can't even do anything without what you are calling built-in macro. Yes, yes. Yes, the compiler needs to have some built-ins for syntax. Okay. Anyone doing anything interesting here? Game jamming? Is there anyone else making a language except for Eduardo? Have you asked Eduardo if his OCaml is working? Like, why is my OCaml, like, language server doesn't work? I asked him once. He said that Rust tooling is worse than OCaml's. I think he's lying to himself. Any contribution requests? Oh, yeah. Actually, you know what? Because I have split the things into crates, you know? You can do that. You can do that. I feel like... So here's my current dependency graph, right? Here's what we have right now. Here's all of the crates that all the libraries that we have made so far. So I think from now on, I'm not going to touch mostly the formatter and the highlighter, at least, right? So you can touch those, maybe. So formatter, and we can try making issues actually, if you want something simple. It's not on the main branch though. I need to rename it to the main branch. Let's rename the current main branch to the old Rust version and then make OXCaml to be the main branch. How do you do that? Commits. Settings. Branches. How do I rename a branch on the GitHub? You know that? Is it not in the settings? View all branches? Oh, this button. Probably, right? Yeah. Main. Rename branch. Old Rust version. Rename. We're going to then rename this to main. And I'm going to make this branch default. How do I change the default branch? Now to be this. That's in the settings now, right? Yeah, okay. Branches. Wait, where? Default branch. Rename. Oh, I don't want to rename the branch. I want to switch to another branch. Main. I understand. Okay, so now in the cast we have just the OCaml, right? Good. Yeah. Let's head to the README. This is rewrite number 3. You can find previous versions in old OCaml version. Branch. Old Rust version. Branch. Okay. Oh, wait a second. It's still pushed to this thing. Yeah. I need to now do git push view origin main, right? Oh, this was rejected because the pushed branch tip is behind its remote counterpart. Wait, what? OCaml playground? What? Its status. Git remote v. Why am I in the OCaml playground? Git remote. Oh, because it was originally as yeah, git remote set URL. Okay, cast lang. Cast. Git push. Still says it's rejected. Didn't update your locals. Git remote. No, git branch. Still in OCaml playground. No, it's not. Cast line cast. Failed to push. Updates were rejected because the push branch tip is behind its remote counterpart. Wait, it's behind? What? Main. As 9 minutes ago. The underscore. Yes. It's not... no. Oh, there we go. Just push works now. Wait, no, this made a new branch called OXCaml. Oh, wait. Git checkout main. No, git branch rename to main. Git push. Current branch has multiple upstream branches. Really? Git push. Git branch. How do I remove the upstream here or something? unset upstream or something. Set upstream 2. Right? Set upstream 2, I was already doing that. Git branch. How to use Git? Hold on. I'll figure it out. I pushed it. That's fine. Okay, anyway. So maybe some of this can be removed. Quantifiers, you want to try that again, but in OCaml? You want to try quantifiers, but in OCaml? I think parser is, I don't know, it still is the hardest part right now to understand. I think it was easier to understand in Rust, actually, but I don't know. Maybe you know OCaml better. Might do that myself, or maybe I don't care. But formatter needs to preserve empty lines between statements or something like that, you know, like if you have code, like, you know, print hello, then you have this print hi, should be formatted into these with just one line. You know, right now, currently, there is no empty preserved. Because I think this is important, right? To preserve the empty line. There is similarly to that the issue where we might need to do the comments, improve comment formatting. I don't know. There's a bunch of things. I'm just going to do it like that. If we talk about this is still kind of opinionated. Like, why can't you have 2 lines? Okay, yes. How do we make it configurable though? We need to then also come up with a way to make it configurable. I think that having an opinionated thing is fine. I have not even thought about how to make it configurable. Once again, this is all custom syntax, so we need to have configuration for custom syntax somehow, right? For highlighting, highlight, allow highlight to generate HTML, you know? So I want to have a cast highlight output HTML or something. Currently only highlights in terminal, you know? I think this is good. Like with that way we can push the highlighted code on the website, right? That we don't have right now. I mean, this is highlighted, but this is highlighted weirdly, right? Using some other syntax. We can use actual, like, cast highlighter. What this is even doing? Like, highlighting it as Rust? This over here is not highlighted, right? Yeah, like that is good. Maybe something else. I don't know. You can look into more, but I think it's mostly about the highlight and the format stuff. You can also add tests. You can also add tests to the formatter and to, I don't know, maybe to highlighter too. Adding tests of the formatter is good. I like having tests here. The other parts probably best not to touch unless you really want to work on the difficult parts, like the quantifiers that you wanted yourself. Okay, we're gonna go here. See Ogma playing Brainoids game. See you guys next time. Bye.